Welcome to Reasons to Believe, the television program where we explore the latest new reasons to believe in Jesus Christ and the accuracy and the reliability of the words of the Bible. Taking a cue from the latest scientific discoveries as a tool for developing these new evidences. And beginning last episode, we launched a series on how to study and analyze creation evolution issues. For those of you who missed our opening episode, they are archived on our website at reasons.org. You can go there anytime to see past airings of our program. And I'm joined again by my colleagues Ken Samples, our resident philosopher and theologian, and our biochemist, Dr. Fuz Rana. And you have a letter for us, Ken, so let's see what we're getting out of the mailbox.
I do. We have a very complimentary letter from Robert from Waretown, New Jersey, and he writes to TBN. He says, I've grown very fond of Reasons to Believe with Hugh Ross. I'm convinced that Hugh and the models of the universe he presents has utterly destroyed the theory of evolution. He explains clearly that if certain events had not occurred many, many years ago, this planet would not be habitable for human beings. In other words, had God not taken specific and precise planning to provide the necessities to promote human life, we would not be here. And he closes the letter by saying, I want to thank TBN for providing airtime for this excellent program. So, very positive letter from one of our viewers in Waretown, New Jersey.
And someone who's actually understanding what we're talking about.
That's right.
That's great.
Well said.
And I think it would be appropriate, too, just to make the point to all of you out there watching or listening to this, that the folks at TBN really do appreciate hearing from you. If you've got comments, you've got suggestions, you want to tell us what's good about the program, if you have a desire for a different time slot, let TBN know. They really appreciate hearing, and basically it's the mail we get in response to our viewers that structures how future shows are put together. So please write in and let the folks at TBN know what you think and what you appreciate and what you don't appreciate. With that, let's get back to our subject at hand. And last time we got together, we discussed this shell game of definitions on creation evolution. How folks have different definitions of creation, different definitions of evolution, and sometimes they'll change the definition without telling you in order to make a philosophical or a theological conclusion against a resistance. But I think today we wanted to kind of look at some of the details of the definitions of evolution used in the biological arena. Last time we made a distinction between the definitions that are common in the physical sciences of astronomy, physics, geophysics, chemistry, and then in biology, anthropology, you see that completely different definitions are used. But even within the arena of biology, Fuzz, there are important distinctions on the definition of evolution. Maybe get us started.
Why don't we first go back and define what specifically we are reacting to when we use the term biological evolution. And this definition is descent with modification, where natural processes guide the development of all living things from a small number of common ancestors. So here the idea is that there were one or two original forms, as Charles Darwin framed it, from which all life that we see throughout the Earth's history, all life that we see today emerged through this descent with modification driven exclusively by natural processes.
Right.
Now, within the theory of evolution, there are a number of different ways in which evolution is used when it refers to organisms evolving. And
just to clarify, this is the definition of change in biology that is used by the naturalists, the evolutionists, people who believe that the changes that we see in life over the history of the Earth is driven through natural process.
Yeah, while we acknowledge that this is the definition, we disagree that the scientific evidence supports biological evolution as defined in this particular way.
Right. But all naturalists would come under the umbrella of that broad definition. Although, as we mentioned last time, in the naturalist camp, there are important distinctions about how the natural process is played out, whether it be through different laws of physics we can't analyze yet or through the physics that we can see. So we'll get into that later, but take it away for us in terms of the biological definitions.
Well, we closed the last episode by talking about microevolution, which is a type of evolution that occurs among organisms, but this is referring to variation that occurs within a species.
Here
here's
it
the
is on
definition.
screen. Yep. Changes within a species due to mutations and or adaptations to environment.
Right, and the idea here is that the species isn't evolving into a new species, but rather what you're seeing is a fluctuation in trait character and combinations of traits that occur naturally within that species as it reacts to variations that are occurring in the environment, variations in predatory pressure, or different types of competitive pressure as members of the same species try to compete for a limited number of resources. And those traits that impart increased survivability, that lead to enhanced reproductive success, are going to be propagated from generation to generation, and over time will occur at a higher frequency than other traits that may not impart the same degree of survivability and reproductive success.
But by microevolution, we're basically meaning small changes within a species. Although there I think we need to be careful because another shell game is being played with the word species. What is a species? But we're basically talking about relatively small changes within a given population. So if you have a broad definition for species, it's within a species. If you have a very narrow definition for species, well, it may actually look like or be claimed to be one species becoming a new species, but when you really look at what's happening, it's still small changes. I remember reading an article in Nature where they claimed that they had proof that speciation was going on in real time, and when you read the article, all you saw was that, well, the parachute size of certain daisies was changing with respect to time. It was still a daisy. It was still the same species of daisy, but the size of the parachute, what I mean by the parachute, kind of like a dandelion is a type of daisy, and it produces this little puffball where it carries off the seed. And of course, if you've got a particular kind of island environment, small parachutes may land on the island, big parachutes will go out to the ocean. So of course, over time, there will be evolution, microevolution of the size of the parachute. But it's not one species changing into a radically different species.
You know, what's interesting is this is where all the evidence, or the majority of the evidence, lies to support biological evolution. So we wouldn't dispute that microevolution occurs, but what's interesting is that this evidence is extrapolated to argue that these macro changes that take place, and we're going to talk about macroevolution in a minute, but these large-scale changes that naturalists, that evolutionary biologists argue for, occurs. So it's a mismatch in the scale of the evidence and the scale of the evolutionary process.
We have the data to support microevolutionary claims, but the claims for macroevolution are all based on extrapolation.
Right. Let's give some more examples of microevolution. One common example that our viewers are probably aware of from biology textbooks is the evolution of beak size on the finches, the Darwin's finches in the Galapagos Islands. And we have a graphic showing people where these islands are located. And this is off of the western coast of South America.
And here again, it's important to recognize that in these Galapagos Islands, they're fairly well separated. The scale may not show the separations here, but the islands vary greatly in size. Some of these islands are big and some are really tiny. So this is going to provide different environmental habitats that could easily drive the breeding of different finch beak sizes.
Now, I believe there are approximately 13 or 14 finches that are found on the Galapagos Islands, and Peter and Rosemary Grant have spent their career studying the finch biology, and what they notice is that beak sizes in the finches can vary with respect to time in response to changes in the moisture content of the environment. When the environment becomes arid, typically the beak size becomes larger because the types of seeds are typically harder under arid conditions and larger, and so you need a larger beak size to be able to feed.
Right.
And as more moisture is introduced into the environment, as there's more rainfall, you see an oscillation back towards a smaller beak size, where these small beak sizes now don't influence survivability.
Well, I think that's really critical because when you read textbooks for high schools and college students, it's implied that the changes are monotonic, that it always goes in one direction. And in fact, the data shows is that it's cyclic. So the beak size goes up, it goes down, it goes up, it goes down over time, rather than getting bigger and bigger and bigger, or smaller and smaller and smaller. So it's not a steady monotonic change, it's really an oscillation.
Well, what's nice about this is that this is a real-time example, but you see the same type of data typically in the fossil record, where you don't see a directional change or gradual evolutionary transformation along a particular trajectory, but again, oscillation that occurs more or less randomly. And I imagine if you spent enough effort and could understand environmental conditions, you could probably correlate environmental changes at certain geological strata with the types of changes that you're seeing in a particular organism that's occurring in the fossil record through the different geological layers.
And over a long time period, of course, there would be the possibility that you could get a smoothed out monotonic effect, but there will be significant oscillations overlapping that monotonic change with respect to time.
But what we're looking at here are not significant changes. These are microevolutionary changes.
Right.
We don't dispute that this is occurring.
Small features in the beak structure and size.
Right, but this is not leading to new species. We're not really seeing biological evolution having creative potential.
It's not a finch becoming a mammal.
That's right. And last time we made the comment that this we view as being a design characteristic that God has built in this capacity within species to be able to vary their trait and characteristic features in order to accommodate different environmental pressures, different predatory pressures that they may experience. This gives them a long-lasting endurance on the face of the earth.
Do you remember when we were discussing one of our previous episodes, the interpretation of Psalm 104? And towards the end of Psalm 104, it speaks about how it's the property of all life to die off, but God recreates. He creates new species to replace those that go extinct. But from the Creator's perspective, it seems that He's preferring not to create too often. And so He designs a species in the first place so they have this possibility for microevolutionary adaptation so they can survive longer in their environment. Otherwise, they would be going extinct very rapidly, and then you'd have the Creator having to intervene much more frequently than He otherwise does. So yeah, I'd agree with you. This is a good design feature that the Creator puts into the species that He creates so that they're able to survive when they change their environment or their habitat. And that's one of the things we talked about in our creation model. The way God has designed our solar system or planet Earth, it changes significantly with respect to time. So from the Creator's perspective, He would want to design species that could, at least to some degree, deal with those changes.
Now, another example of microevolution that I'm sure our viewers are familiar with is the peppered moth in England. And this phenomena was discovered in the 1950s by a scientist named Kettlewell. And what he observed is that the peppered moth, which typically occurs with a light-winged variety, began to develop dark-wing varieties in the population. And he noticed a correlation between increased industrial pollution and the darkening of the peppered moth wings. And at that time, Kettlewell thought what was going on was that the pollutants were killing lichens on the trees, which gave the tree bark kind of a light color so that the moth would blend into the tree and avoid being eaten by birds. But as the lichen died, the light-wing variety was now exposed and readily observed by predators, and so had to evolve a dark-wing variety which was better camouflaged.
Right.
Now, this was an example of a microevolutionary change and supposedly one of the first documented examples of natural selection. Now, it's turned out to be a lot more controversial and complex than this. It may not be that it was actually a response to predatory pressure that caused the wings to change. Some scientists now think it was just simply the introduction of industrial pollutants into the environment that caused these dark-wing varieties. So there's a lot of controversy as to exactly what's going on now with the peppered moth.
General agreement that pollution is a significant causal agent, because now that in Britain they've done significant things to clean up the pollution, we're now seeing light-colored moths come back.
That's right. But the point is that this is a microevolutionary change. We're not getting a new species of moth. It's still the peppered moth. It's just the wing colors are different.
The wing color is the only thing.
So as this is presented as evidence for evolution, this should cause a Christian no concern at all, because this is microevolution. And we should also resist this is being introduced as evidence for large-scale biological change. This doesn't demonstrate anything to that sort.
But by the same token, the Christian should resist the temptation to say, this is wrong. I mean, the evidence for these microevolutionary changes taking place in different species literally is overwhelming. I mean, in one sense, we see it in our own species. You go over to Europe and you see all these suits of armor, and you recognize, well, 700 years ago, people were only about 5 feet tall on the average, and today they're much taller. And that's an example of a microevolutionary change that's occurred in our own species. So,
now, the next level of evolution that we would talk about would be macroevolution. And this is what I think typically causes concern for many Christians, because now natural processes are having the capacity, according to this view, to generate creation.
Here we have it on
creative
screen,
capacities.
Buzz. Macroevolution, large-scale changes in organisms occurring over long time spans, thousands or millions of years, via natural selection or genetic mutations.
this is like a species disappearing and having evolved into a completely different species. Not just breeds like we see with the dogs, but this is dramatic, significant changes in structure.
Right, and we're looking at evolution occurring not even at the species level, but even at the genus and family and order level, and,
Right.
and even higher than that. So kind of,
So it's like a new order appearing.
right, so like birds evolving from dinosaurs would be an example of macroevolution.
Right.
Or even we did a series on Who is Adam, and we talked about these bipedal primates in the fossil record. That would be another example of macroevolution, an ape-like ancestor evolving into modern humans.
Well, probably the most famous one I can think of has been the subject of two specials on the public broadcasting system. Would be this claim that land-dwelling mammals evolved into modern whales. In fact, I think we got a video clip that shows this
And Fuzz,
progression.
could you talk us through
Sure.
this?
Now, this is a wolf-like animal called a mesonicid, and that evolves supposedly over time to live a lifestyle near the edge of the water. And this particular animal is called Ambulocetus, that then evolves into what's called a basilosaur. And then again, through the loss of hind limbs and the acquisition of fins and flippers, eventually evolves into a modern-day whale. Now, this is highly fantasy in my mind, because what's happening is there's a few fossils that are kind of strung together to make the argument that this type of transition is occurring.
Okay, where do we have the bones to support this hypothesis of this very dramatic evolutionary change?
Well, there's a lot of fossil remains in Pakistan, for example.
Right.
In fact, one of the wolf-like ancestors, alleged ancestors to modern whales, is referred to as Pakicetus, meaning in reference to the geological location where
But Pakicetus was already in the water.
it was kind of an animal that could have lived on the water's edge. And when you look at the way the fossil seems to indicate, this organism was perfectly designed to live on the shoreline, both exploiting the land and exploiting the water to feed and to survive.
Right.
So I see these as organisms that were perfectly designed at different time frames in the Earth's history to live different lifestyles. But what evolutionary biologists are doing are looking at these fossil forms and then trying to come up with a story and kind of linking them together and assuming that this transition is occurring.
So they got the bones of these different species, but the hypothesis or the assumption they built into it is that the species, this wolf-like creature, somehow change into this Pakicetus that somehow change into this killer whale. And the time scale for the whole process is, what, 4 million years?
Yeah, it's an incredibly rapid transition, which makes no sense when you think about the magnitude of not only anatomical changes, but physiological changes and even biochemical changes that would have to accompany this type of a transition. It's incredibly rapid, and it's more evolutionary biologists looking for data to fit their preconceived notions and to try to find evidence to buttress this macroevolutionary type of a concept.
Well, I've got a book here called At the Water's Edge, and it's subtitled Macroevolution and the Transformation of Life by the biologist Carl Zimmer. And the whole book is, almost the whole book is focused on the story about whale evolution. And so you can read for yourself how an evolutionist tries to put this whole story together. But yeah, you're right, it's just 4 million years. And the evidence they have is simply the hard body parts, the bones. And it's just recently that evolutionary biologists have been able to critique this story and say, no, wait a minute, you got this creature living on the land, and now we have a creature in fresh water close to the shoreline, lives in the rivers, and then it ventures out into the river's mouth where there's now some salt to deal with. And when you're looking at the modern whale at the end, it's living its whole life in salt water. Now, the bones may not have to change very significantly, but you're looking at very dramatic changes in the internal organs. The kidneys, the liver in particular, the heart, would all have to, and the lungs, of course, would all have to change in dramatic ways. And just looking at the liver and the kidney changes that are necessary to deal with a saltwater environment. And we wrote an article in our Facts and Faith magazine that I believe is posted on our website. People can get the hard copy or they can go to reasons.org. But we talk about the challenge of having to do all this in just 4 million years and an internal organ structure. And when you look at the internal organs that have to be changed, we recognize this is happening so rapidly, it would stress any naturalistic interpretation of how this could happen. I mean, there's really no conceivable way you can get the natural selection and the mutations working to bring about changes that fast. But I think it's significant that this is often the prima facie piece of evidence in support of macroevolution. We have the bones. There's no question these changes took place. But the conclusion is an example of macroevolution through natural changes is something that needs to be disputed, because often people say, well, have you got the evidence that proves the story? No, it simply proves that the changes took place. It doesn't tell you how they took place.
And again, as you look at the lifestyle that you would assume that these organisms had and their anatomical features that we can assess, what we see is evidence, in my opinion, for divine creation, where God is creating these organisms that are perfectly suited to live in different environments on the Earth's history at different time frames. But again, because the time frame is 4 million years, that argues for special creation, not necessarily that these organisms are related to one another in an evolutionary sense at all.
Well, to be fair to the Carl Zimmers of the world, they were trying to claim, well, what you got here is speeded up evolution because the environment is highly tumultuous at that time. But actually, if you look at the history, you discover that the time span where these changes took place 52 million years ago to 48 million years ago, it was a benign period. And so things were relatively calm. And there again, that would mitigate against the idea that you've got some natural prod that's putting in a lot more of these mutations. Not that that would help. Driving up the mutation rate simply means you've got more negative mutations to deal with relative to positive than you had in the first place.
But I think part of the point that we want to make here is not so much refuting whale origins, but really making sure that people understand the distinction between microevolution and macroevolution.
Right.
That there's evidence for microevolution, but oftentimes this evidence is used to support these macroevolutionary changes with a sparse amount of data thrown in from the fossil record.
Well, where the lay person, I think, can ask a good question is time scale. Because in the case of the whales, usually the lay person watching this PBS special says, oh yeah, this took place over 60 million years. But when you ask the question, what exactly is the time scale for all these claimed changes? Oh, it's 4 million years. Suddenly that helps people clarify, well, what really is going on here? And, what are the conditions under which these changes are taking place? And, would this fit a creation perspective? God is dealing with different food supply issues. This could make some sense. But I think this is right. You want to help people think this through.
But, we have to be aware of the shell game that's played with the definitions in terms of providing evidence for the theory of evolution. Because what oftentimes happens is this bait and switch tactic where evolution will be defined, as we mentioned in last week's program, as a process that's a proven fact in the physical arena. We see now some evidence at the microevolutionary level for evolution occurring, and then it's assumed that evolution explains
Here's a shell
life's
game on the
history.
screen here. And very quickly, the world around us changes. That's the physical science definition. Similarly, the fossil record reveals profound changes, no doubt about that. And then species evolved into new species. There's the implied assumption about the causal agent. And so people have jumped from, the well-established database into saying this is how the change took place. Quite unjustified unless you produce the evidence for those changes.
Yeah, we're starting to run out of time, but I think next week we want to show a specific example from a booklet published by the National Academy of Sciences where this shell game is actually being played to argue for biological evolution. This is not something that we're merely making up, but we want to give people a specific example so they can see how it works.
It's in print, and it's right there in the curriculum, science curriculum for high school and college students. So, yeah, it is something that needs to be dealt with and exposed. Well, I want to thank you, gentlemen, for helping us think through these definitions and these issues. And yes, keep watching us. And if you missed this episode or the previous one, go to our website, reasons.org. Thank you. Welcome to Reasons to Believe, the television program where we look at new reasons to believe in the God of the Bible, Jesus Christ, the creator of the universe, and the accuracy and the reliability of the words of the Bible. And this is part 3 of a series of episodes we're doing on how to think about and analyze the creation-evolution issues. And I've invited our colleagues here. We have Ken Samples, our resident theologian and philosopher, and our biochemist, Fuz Rana. And Fuz, how about if we have you just kind of do a quick review for us of this shell game of creation evolution, then we'll dive into the definitions that undergird the naturalistic evolutionary paradigm.
Sure, and we pointed out that...
Before we do that, Ken's got a letter for us to read. Let's go to the mailbox, and we'll get back to you, Fuz.
This is an email letter that we received from Diane, and I wanted to note how important letters are. It's important that people write in and tell us how they like the show or provide some constructive criticism, also communicate to TBN their ideas about our show. Diane writes, I appreciate your television program on TBN, and I hope you'll continue on the network. I just logged onto your website and plan to return often to view your selections. Thank you for bringing much valuable information to us relating to science and the Bible.
Well, thank you for reading that, Ken, and I want to remind all of you out there that it is really important to write TBN and let them know what you think about our program, good and bad, and hey, we read those letters too, and it really helps us to frame future series and future episodes. This series we're doing on how to think about creation evolution is largely a response to the mail and the phone calls we've gotten on this. And also I appreciate you making note, Ken, that we do archive all the television episodes we do here on TBN are archived on our website at reasons.org. So if people want to go back and see a show that we did a year ago or 2 years ago or last week, it's there on our website, literally everything. And so it is good to see that people are going to the website to catch these. That, by the way, has really given us some freedom to do these longer series of programs, kind of like the one we're doing, where it's not just 1 or 2 episodes, but we do a series of episodes and allows us to get into subject matter in greater detail. That's also in response to our constituency. So yes, please keep those letters flowing. And the gentlemen and ladies at TBN very much appreciate hearing what you think about this show. And Fuz, we're going to have you review for us, again, the shell game of creation evolution.
Yeah, and we pointed out that understanding definitions is very important, and many times the definitions that are used to describe the theory of evolution are equivocal in their meaning. They're ambiguous. They can be used in multiple ways. And the term evolution is that type of a term.
Often to political advantage.
That's right. There's a bait and switch tactic that's used where evolution will be defined one way, for example, change in the physical arena. Evidence will be used to support that change, and then during the course of the discussion, the meaning of the term evolution changes, but there's not a simultaneous accompaniment of new evidences to support the new definition that's being used. And an example of this that we made mention of last time was taken from a pamphlet or a booklet more appropriately published by the National Academy of Sciences. And this booklet is called Teaching About Evolution and the Nature of Science. And
So it's targeting what, science teachers in
science
the public schools?
in the public schools, trying to encourage them to teach about evolution and how to teach about evolution. And here's a classic example of the shell game and the bait and switch tactic that appears in the second chapter of this booklet, where they're trying to argue that evolution is a fact. And I think we have a graphic that kind of will walk us through this, where they first describe evolution in terms of the physical sciences, where they say the world around us changes. This simple fact is obvious everywhere we look. Streams wash dirt and stones from higher places to lower places. Untended gardens fill with weeds. These are uncontroversial uses of the term.
And this is a direct quote from the booklet.
This is a direct quote, but these are uncontroversial uses of the term evolution.
Right.
Everybody's familiar with this. We now are convinced that evolution is a fact. Then the passage continues. Similarly, the fossil record reveals profound changes in the kinds of living things that have inhabited our planet over its long history.
That again is a direct quote.
That's a direct quote, but now what they're doing is mentioning that we do see changes in the fossil record.
Right.
But now they're attributing those changes without any evidence to do so to natural selection that operates on random variation. They say more than 99% of the species that have ever lived on the Earth are now extinct, either because all the members of the species died, the species evolved into new species, or split into two or more species. So
there's the bait and switch.
Bait and switch. And now we're talking about microevolution as the evidence to support macroevolution, or the change that we see in the fossil record. But again, we would argue that that change that we see in the fossil record could be God intervening throughout the Earth's history to bring about new life forms at different times in the Earth's history.
But you won't find that in this booklet being sent out to the high school teachers.
Right, but here's an example where the shell game is being used to convince and to encourage high school students, or high school teachers to convince their students that evolution is a fact, playing this shell game, playing this bait and switch tactic.
And this is broader than just the National Academy of Sciences. I mean, we're here in California, and you have what's called the California Science Framework Statement. And that, too, includes this bait and switch shell game of creation and evolution. And therefore, I think our viewers need to understand that this shell game is being widely exploited throughout public education, particularly high school students taking biology are subjected, or at least the teachers are subjected to this shell game, and not all teachers are perceptive that this is a shell game being played, or there's a bait and switch going on here. And therefore we have a real problem when it comes to biology education here in America. Fuzz, you got any comments to add to?
Well, I think it's,
if
I could interrupt, I think it's critical when we talk about these things, because clearly the words are changing meaning, and in the end, something is being supported that is illegitimate. And if we can go back to these definitions, I think it's really critical that we understand what these terms mean and how they're being supported. So.
Okay, thank you, Ken. Now, when we get into the naturalistic evolutionary paradigm for explaining the change of life in biology, Fuzz, what are the most popularly attributed causal agents?
Well, you'll hear the term natural selection used as kind of the way that evolution is driven at the microevolutionary level, as well as one species allegedly evolves into another species, and ultimately how one major group evolves into another major group. The driving force is natural selection. And you can kind of think of well, we have a definition of natural selection here on the screen.
Here it is, Darwin's mechanism of evolution, whereby individuals compete for limited resources. Those with more fit characteristics for survival pass on these advantages to their offspring.
Right, so you can kind of think of natural selection as a filter that's going to select certain traits that are going to impart increased survivability and thereby increased reproductive success, and at the same time prevent other traits from being passed on from generation to generation.
So getting rid of the weak and allowing the strong to survive and reproduce.
Now, oftentimes you'll hear people refer to natural selection as a force, and it's not really a force in the sense that gravity or electromagnetism is a force, but it's kind of viewed, again, metaphorically as a force. And in Charles Darwin's day, he kind of viewed natural selection as being mostly competition among members of the species for a limited number of resources. He was strongly influenced by Thomas Malthus and this whole idea of Malthusian doom, that the planet and humanity is going to come to an end because of overpopulation, and there's just not enough resources to supply the needs of humanity.
Well, that's an important concept to underline, Fuzz, is that we get focused on natural selection mutations, but probably a more fundamental principle is this concept that species overpopulate, that parents produce too many children, and not all the children will survive, therefore the weakest die off, the stronger ones survive. But that's not true of all species of life, that they overpopulate, but that's something that the Darwinists impose upon all life, this principle of significant overpopulation.
Yeah, that very clearly was the way the earliest Darwinists viewed the evolutionary process. I mean, now natural selection also would include predatory pressures as well. Mm-hmm. The organisms that are able to avoid predation because of certain traits that they possess are going to pass those traits on to their offspring.
Right.
And also even just the ability to survive in the environment that they find themselves in is also part of natural selection. So it's kind of a combination of competitive pressures, predatory pressures, and environmental pressures that function as a filter from generation to generation. Mm-hmm. And this is the mechanism for microevolutionary changes that are occurring within a species. Clearly, this is a legitimate force of nature, if you will, in the biological arena. But the question,
in one sense, you could argue that it's a force for no change. What it does is it prevents certain, quote, weak strains evolving the population to something distinctly different. It's all these competitive pressures and the need to deal with the environmental changes that kind of forces through natural selection a species not to change much. And there's been some books put out fairly recently that natural selection is really a very strong argument for stasis, no change, than an argument for change. Any deviation is going to be quickly corrected by the environmental or the predatory pressures.
And that's kind of ironic because that really fits in with a biblical view of life, because you would argue that a creator is going to make life forms to be perfectly suited for their environment and for the predatory pressures that they face, such that any deviation from this ideal design is going to lead to a loss of survivability and loss of reproductive success, not enhanced survivability and enhanced reproductive success.
Right.
So that's kind of the irony here, is that natural selection may not really be that powerful of a force in terms of creating new life forms, but actually preventing evolution from occurring.
Correct.
Now, another term that you'll hear when it comes to the theory of evolution is the term mutation, which is kind of the fuel that provides the variability that you see among members of a species.
Because you've got to natural select on something, and if you haven't got variation in the population, then okay.
Here we have it on screen.
All right.
Mutation, variation, randomly occurring genetic changes, which are usually neutral, sometimes harmful, and may occasionally slightly improve the organism's ability to survive and reproduce.
Okay. Good definition there, and I think it's important to make the point that mutations are a fact of life. We live in a universe where there are things like radiation, ultraviolet radiation, cosmic radiation, radiometric decay. There's heat, there's pressures, and it's these environmental effects that are going to cause mistakes to take place within our genetic material. And that's what mutations basically are. They're mistakes. Nucleotides that are being pulled out from the DNA and the RNA or added in, or simply switch places. I mean, a lot of mutations, you just simply have the building blocks being switched around. So they could be removed, they could be added, they could be switched. From a physical science perspective, it's somewhat analogous to a computer program where your lines of code become corrupted. I mean, in that sense, we can refer to my computer program suffering a mutation. Now, what's typical in a computer program is a single mutation is catastrophic to the operation of the program. One of the arguments I see for design of life forms is that mutations typically are not catastrophic. So if a mutation were to take place within my DNA, I'm still able to survive and continue. It takes a lot of mutations before it threatens my survival, a lot of mutations before it drives change. So there again, the vast majority of mutations are neither harmful nor beneficial. They're simply neutral. And it really is incredible that life can handle the mutation rate that the environment forces upon it. But there are these occasional mutations that are harmful to the species, like having 4 legs instead of 2 legs for human beings. This would be a detrimental mutation as far as we're concerned. Or having no brain instead of a brain. I mean, that's obviously a harmful mutation. But occasionally there are these beneficial mutations. And even that term, I think, needs to be carefully qualified. I mean, a common example I've heard is the mutation that took place in gonorrhea, where a mutation occurred that gave it protection against penicillin invasion, because penicillin became a common way to deal with that disease. And through mutation, gonorrhea became resistant to penicillin. But that same mutation meant that the gonorrhea bacteria was no longer as effective in its capacity to metabolize and reproduce. So in one context, it wasn't so beneficial, but given a penicillin environment, it became very beneficial. And take away the penicillin, it could mutate back. So when we use terms like beneficial and harmful, we have to ask, what is the context under which it's beneficial? And what is the context under which it's harmful? But given that these are genetic mistakes, the expectation and the scientific measurements demonstrate that the vast majority of the ones that are not neutral are indeed harmful. Fuzz, I think the numbers are something like the best you ever see is 10,000 harmful to every beneficial mutation. Right. And more typical, it's 1,000,000 to 1, even 10 million harmful ones to beneficial ones. And this is something that must be factored into any model on how do you get big changes taking place in a species. Natural selection won't get you the big changes. It's going to take mutations. But let's realistically factor in what these mutations are going to do.
Yeah, an evolutionary biologist would look, as a new species emerges, it would have essentially a homogeneous genetic makeup that through these mutations develops a variety of different gene forms that produce the different traits that then natural selection operates on. And I would look at these different traits that are due to genetic variability as something that the creator has already pre-programmed into that species at the time he creates it. Because, as you point out, any type of mutation actually leads to either a neutral situation or a harmful situation. Very rarely do you get an advantage. And if you're talking about 10,000 to 1 harmful to beneficial mutations, you're going to have huge population sizes in order for beneficial mutations to emerge randomly that then can be operated on by natural selection. So it really is a hopeless mechanism in terms of generating viable variability that could actually impart survivability.
Yeah, mutations more typically will drive a species to extinction before it will drive it to significant change. And that's something that needs to be factored into every model on creation evolution. Whether you're a creationist or an evolutionist, we believe mutations happen. But let's see if we can figure out how we can predict what the mutations will do over a period of time for a particular species. And on that basis, we can determine, is it realistic to expect that this will happen under strictly natural conditions, or do you need supernatural intervention and protection? And, that's the part of this whole debate that really is missing, is saying, well, let's look at these mechanisms and put them to the test. Let's see what they can do.
Right. Now, we've been talking about how definitions are so important. And another definition that's important that we understand is the term speciation. And I think we have a graphic that
right.
kind of helps explain to our viewers what that definition is. But speciation is defined as the process of one species evolving into a new species. And so this would be the first stage in the evolutionary process where a new form would emerge. We talked about microevolution as being clearly demonstrated as being part of God's design. This is where now evolutionary biologists argue that microevolution can begin to be extrapolated into some type of creative force to bring about new life forms, and speciation is that level in the evolutionary process where this allegedly occurs.
Right.
Now, the problem with speciation and the term species is just like evolution, this term can take on a wide range of meanings.
So another shell game can be played.
Another shell game can be played with species. In fact, if you look at the scientific literature, you can document probably well over 20 different concepts for species. Nobody knows what a species is.
That's like 20 different definitions of what a species is.
What a species is. And so the idea here is that a microevolutionary change could be viewed as speciation if you define species in one way, but if you define species in a different way, that microevolutionary change is a variation within the species.
Let me give our viewers an example that is modern and up to date. It's the steelhead. It's a fish. And when I was a kid growing up and all into my graduate school days, it was called a trout. And now that they've done a little more study on the steelhead, they said, well, this really isn't a trout, it's a salmon. Well, salmons and trouts, that's two different genera. And so here was a creature they were finding that people have been fishing for a long, long time. I mean, you know, steelheads are quite well known and studied. And yet there was confusion as to what genus to put the steelhead in. And just recently it switched genus. Instead of being in the trout genus, it's now been classified in the salmon genus. So it kind of shows the difficulty of trying to define what a species is, or even to define what a genus is.
Mm-hmm. Yeah, and some of the different definitions are useful in certain contexts, but have limitations in other contexts. And so it's important to recognize that nobody's clearly able to define a species. And what we want to do is kind of review three major concepts that fall within the term species. And we have a graphics for this. We're calling one particular concept anatomical, another biological, and the third genetic. And the idea with an anatomical definition of a species is things that look different are considered to be different species. That's easy enough to understand.
You're talking morphology, like the fossils, the body type,
right,
and look.
Well, and this is, when you're looking at the fossil record, this is what you have to use as a definition for a species.
Because all you got is the bones.
All you got is the bones.
Typically.
But the problem is that many species show a high degree of plasticity, is the biological term or the scientific term, which means they show a wide range of variability in their anatomical features. Dogs are a classic example. You know,
so you dig up the fossils of a particular species and you see a lot of variation.
And is that due to speciation, or is it the natural variation that occurs within that species? Kind of a silly example, but suppose we're looking at three different fossil layers, and on the earliest layer we discover a Chihuahua fossil skeleton. The next level we discover, let's say, a Springer Spaniel. On the third level we discover a sheepdog. Three different body sizes, and if we look at them and we say, wow, the Chihuahua came first, and then the Springer Spaniel, and then the sheepdog, clearly this dog-like animal is evolving to get larger and larger, and we have three different species. Well, we know, because we have familiarity with dogs, how variable they are in their anatomy, and so it's not really a great way to define a species, but in certain contexts,
that's all you got.
That's all you got.
Right.
The biological species concept is something that everybody's probably familiar with, because this is the definition that shows up in high school textbooks, and it basically says a species is an interbreeding population that when the members of that species interbreed, they produce an offspring that not only is viable, but it also is able to reproduce in kind. But the problem is that in the wild, you see these species that are morphologically indistinguishable from one another, yet they won't, but they won't interbreed. And they won't interbreed not because they can't, but because they just have this preference not to interbreed with one another.
So it may not be biologically driven or morphologically driven, the fact that they don't breed. It becomes more of a social structure.
Yeah, an example is in Western Australia, there are these two fruit fly species that are morphologically indistinguishable, and they're considered to be different species because they don't interbreed. But if you take them into the laboratory, you can force them to interbreed. They produce viable offsprings that can reproduce.
Wow.
And what turns out, what keeps them from interbreeding in the wild are different hydrocarbons in their exoskeleton that make them smell differently. And you can actually see how these hydrocarbons can change from generation to generation in their exoskeleton.
Boy, wait till the perfume industry finds out about this.
Yeah, but the whole point is that you could call this a speciation event, and by one definition it is, but really there's no creativity happening in the natural process that's driving the speciation. It's really a microevolutionary change that's being classified as a new species. And the third concept is the genetic concept, where differences in the genetic code or the DNA sequences are used to define different species. But
So that'd
again,
be a chemical definition. You look at the chemistry
Right.
of different
Right.
individuals to determine if the chemistry is similar enough that they should be classified as part of a species or not.
But here you get into problems as well, because, for example, a paper published recently, I believe it was in Nature, showed that the African elephant is actually two species. They don't look different, but they have a different genetic makeup. And I'm willing to bet they could actually interbreed and produce viable offspring. Or another discovery recently is the lynx, which was thought to be two species because they look different, but when you look at the genetic makeup, it's identical enough that you would say this is a single species. So the whole point is that when you say speciation is occurring, is it really a microevolutionary change, or is it really a new species that's being produced? And more often than not, it really is a microevolutionary change that's being touted as a speciation event.
Right. And these are just three out of what, 24 different definitions of species, and yet they're contradictory.
Right.
So there's no consistency in the definition of these species.
Right.
Well,
So-
Ken, before we end up, why is it important to understand the distinctions in these definitions?
Well, Hugh, we communicate our ideas through words, and if words lack clarity, either because they're ambiguous, they have multiple meanings, or because they're vague, they're blurred or fuzzy, we are left with confusion. And it's easy to manipulate words and draw conclusions that are not based on the facts. And I think through the shell game, we've seen that kind of thing happen, and it can happen among evolutionists as well as among creationists.
It explains why there's so much confusion in the biological literature on the idea of speciation. There is confusion because there's so much disagreement on the different definitions.
Right.
And so even within the evolution of biological camp, there's a confusion about the position that they should be promoting and teaching. Well, thank you for that, Ken, and we'll be back with you next time. Welcome to Reasons to Believe, the television program where we look at new reasons to believe in the God of the Bible, the accuracy and the reliability, the words of the Bible. And we've been doing a series on how to think about creation evolution issues, how to think about how to analyze it. And last time we ended up on a little discussion of contrasting worldviews. And Ken, I'm going to ask you to kind of give a little bit of a review where we left off last time, then we can take off from there.
Sure. We were talking about worldviews, and a worldview is a conceptual framework that helps us interpret reality. And I like to think of a worldview as a pair of glasses, because everything comes in through those lenses. And where we ended up is talking about how a worldview affects the way we conduct science. And in fact, we had 3 points that we were making, and I believe that we have a graphic on this.
Right.
Number 1, worldviews affect how we interpret data. Number 2, worldviews involve a network of beliefs influencing each other. And 3, a worldview can cause us to avoid or force-fit data, which of course would be a negative aspect in that discussion of worldviews.
And we covered the first point in some detail in our last episode, and incidentally, if any of you want to see that, they are archived on our website at reasons.org, as all of our television episodes are. And so we can just pick up right there. But we primarily want to give an overview of what we covered in the last part of our previous episode on the second point.
Right.
So if you can take that up, and then we'll really get into point 3.
Right. We talked about this question of networking, and the example that we used was how a naturalistic worldview, if that's your foundational belief that nature is all there is, then that has a series of other beliefs that are built on top of it.
Right.
And I think what we want to do now is to show that this can also take place among Christians. Mm-hmm. And our example is going to be a discussion of young earth creationist point of view. And we'll begin with...
we covered the naturalists last time.
That's right. So here's a contrast with a Christian approach.
And the whole point is that regardless of your worldview perspective, you got to watch out for these things. And we
Yes.
need to expect that this is going to creep into our thinking. Our natural mind, to put it in the context of the book of Romans, wants to go there.
Right.
So we always have to be on the lookout for this taking place.
Right, and the point we want to focus on is this challenge that creation isn't scientifically testable. There are naturalists who affirm that. We looked at it last time.
Right.
But there are also Christians who would say, as we see on screen, creation isn't scientifically testable. How did I arrive at this belief? Where do I go from here?
Right.
And so this is a criticism that can be brought to bear both with the naturalists and with young earth creationists.
And they're not alone, but this is probably the most obvious example of where this takes place within the Christian creationist camp.
Right. Now let's take a look at how they would build a network of beliefs. And I think we have another graphic here. Right on the bottom of that pyramid, we have the Bible is our only source of true knowledge.
Or often how it's put as the Bible is their only reliable source of true knowledge. They will admit there are
Right.
other sources, but the Bible is the most trustworthy or the most reliable or the only one you can really trust. So it's a subtle way that same foundational belief is often stated to audiences.
And I might note that that's not the same as the historic Protestant position of sola scriptura, which says the Bible is the supreme authority, but it doesn't deny that there are other authorities and that those other authorities are reliable, trustworthy, and helpful.
Correct.
So this is a little bit of a divergent view from historic Protestant thinking.
Sometimes there's a debate over what John Calvin really believed about these issues.
Right, certainly. Now, if we take that view that that only what we get out of the Bible is reliable, we can then build a belief on that. And I think we have another graphic. So our next link there. Bible is the only source of true knowledge, and now science and scientists are untrustworthy.
Or to put it often how it's the non-Christian scientists and non-Christian science is untrustworthy. Christians who disagree with us are untrustworthy. So often it's framed in no sense. In other words, some science is trustworthy, but
Now, why, Hugh, would that come up? I mean, what's behind that idea that scientists are untrustworthy? Why would a young Earth creationist even make that criticism to begin with?
well, often they're saying that because of their training, they're untrustworthy. In other words, their training comes from a non-Christian worldview perspective, and because they have been, quote, brainwashed in this worldview perspective for so many years. I mean, it often takes 20 years to get a scientist to complete his education. And so they will claim, well, they've been saturated with 20 years of propaganda, and therefore you can't trust what a scientist will say. They'll say that about Christian scientists, that because they've gone to secular institutions, they've been subject to this propaganda, and therefore, even though they are a believer, they can't be trusted.
Now, another belief that we could build on this pyramid.
By the way, I should also add this. There's also the comment, well, because of their fallen nature,
Yeah.
they're not trustworthy. Right.
Now let's build on that. We've talked about the Bible is the only trustworthy authority. We then move to the question of scientists not being trustworthy, and again, as we look to our pyramid, no one was there to observe creation, and so what can scientists really tell us if the creation was long before any human beings stood on the planet or were able to observe it, and so nobody was there? How often do you hear that criticism?
I hear that a lot, but particularly in my discipline, people will say, well, Hugh, you weren't there to observe the creation. How can you make these statements with such great confidence? And there's a confusion there between what is direct observation and what is indirect observation. But as I've said before in this show, in the case of astronomy, it's direct observation of the creation. So we astronomers really can observe creation. And that's because it takes time for the light to reach us, and therefore we're actually looking back in time and making a direct observation of the past. But Fuzz, I think you would agree that the methods in biochemistry, for example, are not all that indirect, and therefore that scientists have tools for directly inferring what was taking place, say, at the creation of life. It's not something that is so obfuscated by instrumental problems that we really have only a kind of a murky view of what was going on there. So it really boils down to debate, Ken, how clearly do we see the past? But to claim that we don't see the past at all is an error. It's not only an overstatement, it's an outright error.
Okay, and this, of course, brings us to look at the last point of our pyramid here. Moving up, the Bible's the only source of authority. Scientists or science is untrustworthy. No one can observe creation. And then finally, creation isn't scientifically testable. And that's something that you would challenge both a naturalist and young earth creationist about, that Reasons to Believe affirms that creation is testable. Our theories about it are.
Well, I would agree with them in this context, however, Ken, if it's really true that it's impossible to observe these events or to measure anything or to test anything, then yeah, creation is not testable. And creation evolution issues at a philosophical level are immune to testing. But the real point is it's not correct that we can't observe, we can't measure, we can't test. We can do those things.
Right.
And therefore this brings us into the scientific realm and therefore forces an integration of philosophy, theology, and science. But I think you'd be agreeing with us too that because of the specialization that takes place in the theological education or philosophical education or scientific education, you do get a lot of people on all sides of the fence who would prefer not to have to mix the theology, the philosophy, and the science. I mean, as a scientist, and I've never taken courses on philosophy and theology, I'm going to be highly motivated to work in this arena where I don't have to pay attention to the philosophers and the theologians.
Right. And vice versa.
And vice versa. It's going on all sides. So sometimes it's not so much a worldview problem as an educational problem or a communication problem.
Right. Now, we also talked about a third point in our list of them, that worldviews can sometimes be defective. A defective worldview could cause us to avoid data, ignore data, or to force fit it. It doesn't quite fit with us, with our theory, and so we kind of force it there. Worldviews can cause us to avoid or force fit data.
And it might be good to point out that in some respect, all worldviews have defects.
Right.
And,
right.
Therefore, there's a need for us to be testing our worldviews. But I think what's happening here is that people are pretending, well, my worldview is perfect. There are no defects.
Or they may not even realize that they have a worldview.
Sure.
Everybody has a worldview. Everybody operates according to a worldview. But if you're not cognizant of your worldview and how the worldview you have impacts your reasoning, then you seem to be impervious to that fact.
For that reason alone, they should take courses in philosophy, right?
Yeah, and I think a good way of putting this is that every worldview has strengths and weaknesses. Obviously, some worldviews are maybe largely incoherent, but other worldviews, a theistic, Christian theistic worldview has strengths. It may have challenges. How do we explain the problem of evil or something of that nature?
Right.
But we can turn that also back to the naturalist. They may have strengths, but they also may have challenges.
And the greater the challenges, the greater the temptation to force fit the data or to simply avoid looking at data.
Right. And I think, to be intellectually honest, we don't want to ignore data. We don't want to force fit data. We don't want to suppress data that challenges our view. Rather, we may want to reshuffle our worldview. We may want to alter our worldview if there are very serious challenges to it. And this is what you're talking about when you say that we may have to make some adjustments.
Right. Or, if you're really confident about your worldview, sometimes you might want to question the observations. This happens a lot in science, where they say, well, are you really certain there aren't some instrumental defects here that are giving us these measurements, these results? And so that's motivation to redo the experiment with a different piece of equipment. and see if you get the same results.
But if all you're doing is spending your time questioning the results as opposed to questioning the worldview from time to time, that's an indicator that maybe the worldview has a problem.
Right. I mean, if you got enough experiments done, you say, well, hey, it's not an instrumental problem. It's a philosophical problem.
Now, I think we have an example of how data can be avoided from both a Christian perspective and from a naturalistic perspective.
Right.
And the first example that we want to illustrate this point with comes from a statement made by a young Earth creationist, Kent Hovind. If we have a graphic, I think, that shows his statement, and this came from a program called What Killed the Dinosaurs on Encounters with the Unexplained. And Kent Hovind says the Bible teaches very clearly in Exodus 20:11 that God made everything in 6 days, which means that man had to live with dinosaurs. They called them dragons. Now, this is a real interesting statement, and maybe, Ken, you could take us through how this particular belief was arrived at, and we can maybe evaluate what type of data is being ignored or forced into this statement.
Avoided.
Or avoided.
Yeah.
Okay, we've been presenting this theme that there is always a foundational belief. And I think critical to the young Earth position, Kent Hovind being a young Earther, is his conviction that the Earth is only several thousand years old, 8,000 years old. So if we place our pyramid up there one more time, we see that right at the bottom is that foundational belief. The Earth is 8,000 years old.
Plus or minus 1,000 or 2.
Okay?
Yeah.
And obviously a foundational belief is going to have, again, a network of beliefs, and we're going to build some beliefs on top of that.
Or in the case of the Earth being 8,000 years old, you can even back up and step and say Exodus 20:11 forces this 8,000 year.
That's right. That's right. The Earth is 8,000 years old. Through looking at this passage, the inference they draw is that it's only several thousand years old. And we build on top of that, there were dinosaurs. Dinosaurs existed.
We got the bones. We know they existed.
So we've got our second tier there, dinosaurs existed. And we build, again, on top of that, that if the Earth is 8,000 years old and dinosaurs existed, then human beings must have existed at the same time. Dinosaurs lived with man.
That's because we have evidence that humans have been around for 8,000 years plus.
Right.
So
we then draw our conclusion right at the top of the pyramid. 8,000-year-old Earth, dinosaurs existed. They must have existed with man, and therefore these so-called dragon legends are true.
right.
And now, of course, the question is this a suppression of evidence? Is this an ignoring of data? And what kinds of data would they be ignoring in bringing this about?
I think we have a graphic that summarizes the type of data that's ignored.
At least gives a few examples of some of the avoidance.
Right, in terms of when you're establishing this foundational statement that the Earth is 8,000 years old. And this includes biblical data, a whole host of scientific data, including radiometric dating, the geological column, the fossil record, and light travel time. And maybe we could start with the biblical data that's ignored. I mean, this idea that the Earth is 8,000 years old is an interpretation of a biblical text in isolation, as opposed to a necessary statement that emanates from Scripture.
Well, it's interesting, Fuzz, because in the television debate I had with Kent Hovind on this issue, he raised Exodus 20. And my response is, well, wait a minute. This is given to us 5 different times in the Levitical law. Let's look at all 5 passages. And what you discover in the context of all 5 passages on the 10 Commandments that you find in Exodus and Numbers and Leviticus and Deuteronomy, that it's not as clear-cut as what Kent Hovind was suggesting. Sure, it talks about 6 days, but it doesn't specify that the 6 days are 24 hours. In fact, what you discover in those alternate passages is that there are examples where the work week is 6 years plus 1 year for the agricultural land, for the slave that was to be set free in the Sabbath year. And therefore, what we see in Exodus chapter 20 is an analogy, not an equation. But you may not pick that up if all you look at is one verse. So one of the things you have to avoid here is one verse theology.
Right.
Or for that matter, you could even look at Exodus 20 and say, no, wait a minute, that's verse 11. Let's go back to verse 9 and see what that's got to say. So, just even stepping back a verse or two.
And I think looking at context is as well. Often the debate centers around the word yom. If it has a numeral before it, the assertion is it must be a literal day or a day of 24 hours. But when you begin to look at the entire Bible in the use of yom, you begin to see other things. And so, and I think that's a fundamental principle of studying the Bible. We don't want to suppress a series of verses just to push, our pet theory. Ultimately, we want the Bible to be allowed to speak to us in its full context.
We do, and there's really no substitute for reading through the entire Bible and the content of that topic. Rather than just picking one creation account, let's look at everything.
And systematizing it.
Systematizing. I mean, I remember one young earth creationist I talked to at a seminary said, well, look at all these usages of the word yom in the Old Testament. The majority fit the 24-hour literal interpretation of the word. And I said, well, notice that those verses you're quoting are all in the context of human history. What if we were to eliminate all the verses that talk about human history and only look at those passages that deal with natural history? Now you discover that the weight of evidence is on the literal interpretation or the literal definition of the word as a long period of time. So in that sense, context is very important.
Right.
Human beings aren't the same as planet Earth. The agricultural land isn't the same as human beings. God is not the same as either of those two.
And there are a variety of passages, not just in the book of Genesis, but throughout the Bible, that talk about the antiquity of the world and the earth.
Right.
And so there's biblical data for an old earth position. It's not merely a critiquing of the young earth position.
Now, a good question a lay person could ask in that context, well, that's a very interesting Bible verse. Are there any other Bible verses that deal with this theme or this question? And tell me what those verses are. Give me the context of each of those verses. And so this is one of the helpful ways a lay person can look at this issue in the context. Is there any biblical data that's being avoided? Another way to look at it is say, well, these English translations are great. How does it read in the original language? That is a little closer to the biblical database, and check it out that way.
Right. Now, what about this scientific data that's ignored or suppressed?
Well, just simply looking at the geological column testifies to the fact that the Earth has great antiquity, and through the use of radiometric dating, we can nail down the age of the Earth and the age of different geological layers to a high degree of accuracy and a high degree of precision. And there are probably over 40 different radiometric methods. Each method has limitations, each has advantages, each is appropriate for different time eras in the Earth's history. And many times geological layers are dated with a multiple collection of techniques, not just only radiometric, but non-radiometric techniques. So there's just a plethora of data that all argues for the antiquity of the Earth, and we can, again, with a high degree of accuracy, a high degree of precision, come to some understanding as to what is indeed the age of the Earth at a specific geological time frame.
Well, a specific way you can apply that to dinosaurs is that the scientific community is now aware that certain asteroid and comet collision events are responsible for bringing about the extinction of the dinosaurs. And we can find evidence for these cratering events, and there are ways to date that, to date the cratering events, to date the tektites that come out of these events, and then that tells you when these dinosaurs lived.
Right.
And even as we look at the fossil record, we recognize that dinosaurs only existed in certain geological layers that include the Triassic, Jurassic, and the Cretaceous period.
That there are distinct layers for the dinosaurs. Or another way a layman could ask a good question, is it possible that the Earth at one time could house all the dinosaurs that we see in the fossil record? I mean, there's a good reason why you got the Triassic dinosaurs coming at a different time than the Jurassic and the Cretaceous. These are big creatures. And the Earth provides us with a limited amount of living space and ecological niches that these dinosaurs can take advantage of. Just simply looking at the fossil evidence, is it reasonable that they all lived at the same time? Is it reasonable that they all lived at the same time as the birds and mammals that we see on the planet today? Because that's really what Kent Hovind is saying, is that they all cohabited at the same time. Is that geologically possible? Is it physically possible you could put them all on the planet at the same time?
Yeah, and dinosaurs clearly have gone extinct since 65 million years ago, and the first evidence for modern humans in the fossil record and the archaeological record is around 40,000 years ago. So there's a huge time difference that
Sure.
separates the appearance of modern humans and the extinction of dinosaurs.
So we really have a problem when we have a worldview and the data that we're supposed to interpret through that worldview, really the data collides with our worldview. It conflicts. Our worldview really doesn't function in terms of being or having what I would call explanatory power. In reality, there is contradiction.
Well, to give you an idea of the degree of avoidance that would be behind Kent Hovind's statement, you practically have to ignore all of the astronomical database. I mean, everywhere we look in the universe and our galaxy, we see evidence that the stars and galaxies and planets have been there a lot longer than a few thousand years. Even the craters on the moon are adequate to demonstrate the moon's been there for billions of years. And then you go to geology. You can look at the erosion that's been taking place at the base of the mountains. And clearly that's not something accumulated only over thousands of years. The erosion debris would take much longer than that, the cutting of the rivers, the plate tectonics that we see in the face of the Earth. If you put that all in a few thousand years, then life would have been wiped out. So the fact that life is even here tells us these processes have been going on for a lot longer. And so, as a number of scientists pointed out in the early 1980s, if we really take this young Earth worldview seriously, then virtually the entire physical science record must be rejected, must be avoided. And this is why there is such a strong reaction to young Earth creationism in the scientific community. They say we've got good reasons to believe that what physics and astronomy and geology are telling us is true. There's overwhelming evidence. And you have to simply either erase that or hide from it in order to support this young Earth message.
And a good theory, a good explanatory theory, which again functions in the concept of a worldview, that it needs to fit the facts. It needs to explain the facts. If a theory collides with the facts, if we have to ignore all of these areas of science, so this is why there is such strong reaction in the secular scientific community, because you'd virtually have to turn aside all of these well-verified views and understandings.
Well, this is what makes the creation-evolution debate such a hostile debate, is because of these worldview problems and the degree to which people are avoiding the evidence, avoiding the database. And it's not just young Earth creationists that do this. People on both sides of the fence are doing this. The naturalists, the evolutionists are likewise playing the same game of pretending the data simply isn't there, of refusing to look at the evidence that's counter to the worldview. Now, it looks like we don't have time to really fully develop what that challenge or what that avoidance would be in the naturalist side. But we'll pick that up on our next episode and really demonstrate that this is really at the very heart of trying to resolve the creation-evolution debate, is pointing out those areas where evidence is being avoided and how to help people around those roadblocks. We'll do that next time. Thank you. Welcome to Reasons to Believe, the television program where we explore new reasons to believe in the God of the Bible and the reliability and the accuracy of the words of the Bible. And hey, if you've missed previous episodes, they're archived on our website at reasons.org. We're doing a series right now on how to think about and analyze creation-evolution issues and disputes and debates. And so you can go to our website and check that out. And also I want to encourage you that if you enjoy this program, please write in and tell TBN that you do like this show. And it would be helpful for us if you can tell us why you like the show. I mean, we really do seriously consider the comments that you write in as planning future episodes. So if you're enjoying this show, please tell TBN thank you for keeping this show on the air, and let us know what it is that you like about the show hey, if you want changes, we'd appreciate you hearing about that too. You got questions, we really do appreciate those letters. And Ken, we're kind of in the middle of this series on how to think about and analyze creation evolution issues. And as our resident philosopher here, you're really helping us through the problem of worldview. And I think we're recognizing as a team here that, you know, it's not just a matter of looking at the scientific and biblical evidence and consistently putting it together. We have to recognize where worldview dynamics is heating up the level of hostility. I mean, the thing that amazed me when I came here to America from Canada was just to discover how heated this debate on creation evolution is, and how unwilling people are to come together in meaningful dialogue to resolve these issues. Like, people aren't interested in resolution. They're simply interested in crushing people who disagree with them. And a lot of it has to do with worldview ideology. And we give an example of some of the abuse of that in the Christian perspective. I think we want to look at it from the non-Christian perspective and just show how this is a problem across the board. But maybe you could just start off here and help us quickly review the three aspects of a worldview.
Yeah, again, a worldview is a lot like a pair of glasses, looking through the lenses. And we've talked about 3 points that I think we want to bring up on the screen. A worldview, number one, affects how we interpret data. We look at the data through our worldview glasses. Number two, a worldview involves a network of other beliefs. And so it's like building a pyramid of beliefs. And three, a worldview can be defective if, in fact, it causes us to avoid or suppress or to force fit data. And so everybody has a worldview. None of us stand in a neutral position without presuppositions and biases. And we bring our worldview presuppositions to all of these things.
We do, and none of us has a perfect or a fully developed worldview either. Every worldview is going to have some inadequacies and defects in it. But I think this third point that you made, that a worldview will cause individuals to avoid data that doesn't fit their worldview, or to ignore data that doesn't fit their worldview. And we gave a good example of how that happens, say, from a younger creationist perspective last week. I think we want to look at how that happens from an atheistic, naturalistic perspective, how there's this avoidance of the data and this force-fitting of the database.
Right. Fuzz, why don't you talk us through this life arising through natural processes?
Sure, and we have a graphic that kind of kicks this off. And this is basically the conclusion that naturalists will arrive at, is that, again, life rose strictly through the outworkings of the laws of chemistry and physics, through natural processes exclusively. And we have another graphic that kind of sets up a pyramid like we've been doing in past weeks, which starts off by laying out the foundational belief, namely that the physical universe is the ultimate reality, that there's nothing beyond the universe. And the related belief to this, then, would be that all supernatural explanations are excluded from consideration. And of course, this makes sense if you think that all there is in terms of reality is a universe as a brute fact. Now, the dependent belief then upon this pyramidal structure that we're building is that then life must have arisen by chance processes. And of course, the conclusion then from this is that chaos theory, some self-organizing principles, some hidden laws of physics, or something must be at operation in order to explain how life could have arisen by chance process, given all the data that currently suggests that this type of an event is really very difficult to accept given the data that we have at hand.
You know, and this is really prominent in the scientific literature and even the books written for lay people trying to explain evolution. What I find common among all of them is the admission, number one, that the probability of life arising by natural circumstances is very unlikely. I mean, one of the books I got here is by, this one, Richard Dawkins, one of the more famous evolutionists, British biologist. And he recently wrote this book called Climbing Mount Improbable. And he admits that there is this huge improbability against the origin of life and the development of life thereafter. but then tries to come up with a naturalistic pathway through avoiding a lot of data that you can get past these huge improbabilities, basically through claiming that life in molecules as a way to store memory until it needs it. And then you have this one, the Gaia hypothesis. And there are a number of scientists today that actually deify planet Earth. They will claim that there's a Mother Earth that's got a personality and a mind. And this intelligence endowed into Mother Earth is what's responsible for the origin of life and the development of life on the planet. So in one sense, it's not an atheist worldview, but it actually makes the planet Earth a god. Then there's this book by Niles Eldredge you've talked about, Fuzz. The triumph of evolution, the failure of creationism. And he says, well, it looks like life just naturally emerges. Life is suddenly here. And he's correct in that perspective, that life instantly arises on planet Earth once conditions make that origin of life possible. And then he says, well, there's got to be some intrinsic principle to the laws of physics, to planet Earth, that just makes this sudden appearance happen. And then finally, you've got Stuart Kauffman in his book Investigations, where he speculates that there's this fourth law of thermodynamics. And actually, it goes beyond that. He says there must be a fourth law of thermodynamics. What he means by that is a law that says that in complex systems, things will arise with greater and greater complexity and information content over time. And what he's really doing is saying, well, obviously, when you look at the history of life on planet Earth, complexity has gotten greater over time. Since there is no God, then there must be this fourth law of thermodynamics. And now he's ignoring all the evidence for the second law of thermodynamics, which says that natural systems tend towards decay over time. And he says, well, no. What we see in biology is they don't tend towards decay, they tend towards increasing complexity. But one of the things I do appreciate about Stuart Kauffman, he does admit that he has zero experimental and observational evidence in favor of a fourth law of thermodynamics. So this just gives you an idea of the extent to which this is taking place in the academic community today.
And I think something that I would want the people who are watching our program to think about in the context of worldviews is that that foundational belief, in this case, that the physical universe is the ultimate reality, that foundational belief really sets what conclusions you're going to be able to draw about how life got here.
Right.
God is ruled out based upon a further belief. There's no supernatural. So it's, so to speak, evolution, a naturalistic approach to the origin of life is the only game in town.
Right.
And so philosophical and foundational beliefs are critical in how people view science and how they interpret these scientific theories.
And the worldview is so dominant that in the face of the data that suggests that life should not have arisen by natural processes, what you're doing is coming up with these exotic, unrealistic explanations, again, because you're driven to that point from your worldview, from your philosophical bias that you're bringing it to the table as you try to resolve the problem of how life first appeared on Earth.
Well, I think we've got a graphic here that breaks down how or in what ways the data is ignored, how people are avoiding. So life arose by chance, 4 different areas where data is ignored: biblical, biochemical, astronomical, mathematical. And Fuzz, you want to take us through these?
Well, I think just from the standpoint of the data that's ignored from a biblical perspective, again, is this whole idea that the Bible may, in some way, shape, or form, serve as a revelation to man from a supernatural being, from the God of the Bible. And the Bible teaches us that there is a creator who is responsible for life, responsible for life's major groups and the diversity of life that we see throughout the Earth's history, and responsible ultimately for mankind. And this data is simply ignored as even being possible by original life researchers and the scientific community at large.
Right.
And creation, from a biblical perspective, is such a critical doctrine. I don't think we realize sometimes how much of the Bible is given to a discussion of origins.
Right.
Now, in terms of the scientific data, there's biochemical and chemical data. From a chemical standpoint, original life researchers have been reasonably successful at generating life molecules, at least simple life molecules like amino acids and nucleotides and fatty acids, but they can't show that these reactions would actually operate on the early Earth's conditions. As soon as you take these reactions that they can get to work in the laboratory and try to run these reactions under realistic conditions that would have been available on the early Earth, the reactions no longer work. So here's data that's being ignored, and what's being chosen is data selectively that seems to indicate these reactions are possible, at least in a laboratory setting. So this is held up as evidence that spurs them on, when in fact, as they look at the evidence more realistically, they would realize that really there's not any hope at all in chemical evidence supporting the origin of life. And from a biochemical standpoint, when we look inside the cell, we just see this incredible amount of evidence that points to this type of chemistry as being designed. You know, it's incredibly elegant chemistry, highly sophisticated chemistry, vastly complex, highly integrated, tightly orchestrated chemical systems that just, even on the surface, just scream out that there is a designer that's responsible for the chemistry that we see inside living systems.
Now, I want to help lay people understand how they can expose this avoiding of the data, ignoring of the database, and what are some good questions that a lay person could ask that hasn't taken a lot of courses in biochemistry. I mean, I think every textbook I've seen at the high school level talks about this Stanley Miller, Harold Urey experiment, where you take these molecules like water, methane, and ammonia and spark it, and you get these amino acids. Well, how complex of a molecule is an amino acid? And you discover, well, it's not that complicated. We're looking at a couple of dozen atoms or less. Have you done anything more complex? In these experiments, have you ever come up with DNA molecules or complex proteins? And then you discover, no, they haven't done that. If you start with the proteins and the DNA and the RNA, can you make a life in the lab? And let's start with the complex stuff. What do you get then? Well, that doesn't work either. And so just being able to ask good questions, right. And you don't have to be an expert to ask good questions, just how extensive is this database? Tell me where the holes are. It sounds like there are no holes. Well, let's follow that up. What have you done past the molecule glycine? I mean, a good question to ask is, in this spark experiment, did you get all the amino acids you need for life? And did you get any amino acids you don't need for life? Did you get any products that would get in the way? And can you demonstrate that this is a realistic circumstance for the early Earth?
Right. And, as you look at the chemistry that you see inside living systems, and you see all these different aspects of that chemistry that are suggestive of design, to simply ignore the possibility of an intelligent designer or a supernatural creator is poor science.
Right.
At least we are rational to consider this as a possibility, and we should be trying to design experiments to see if we can further probe that question, along with the questions pertaining to, could this chemistry emerge through natural processes?
Maybe a good question to ask is, well, just how complex are the molecules inside the cell? Do they show any evidences of design? Do they show any evidences of working synergistically together like machines in a factory? What do you got here? But I think the perception of the public is that we don't have anything, and that's simply not true. We do have that kind of data available today.
Mm-hmm. And even, astronomy speaks very strongly to the improbability of the origin of life through natural processes. And you have the origin of life really is a multidisciplinary research effort, but you have chemists off in the lab trying to come up with chemical routes to produce amino acids, and biochemists looking at chemical systems inside the cell, and they just don't seem to be talking with one another. And you even have the problem further exacerbated because chemists and biochemists aren't talking to astronomers about how realistic is an origin of life scenario given the constraints that astronomy has discovered regarding the universe and the Earth's history.
Or to put it in a little different kind of context, we have the launching just a few months ago of the journal Astrobiology. And to a large degree, that journal is motivated by the recognition that we cannot explain the origin of life on planet Earth with a naturalistic paradigm. Therefore, they're looking to the stars for the answer of how life got here. Life somehow is transported here. And so this brings up the question, is this astronomically reasonable? Is it possible for a bacterium to travel through space? Is it possible we could find some place beyond planet Earth where you can get homochiral amino acids where they're all oriented left-handed or right-handed, for example. Is that a possibility? And then, how do we explain the fact that, planet Earth has these conditions necessary for the support of life? Is it possible that there are other planets elsewhere in the universe where the same conditions would arise, or is Earth really alone? So, and then do we have enough time? Astronomy tells you we've got enough time. And, we only have 14 billion years to make all this happen. Sounds like a lot of time until you get into the biochemical difficulties. Then you realize 14 billion years is not anywhere near enough time.
Yeah, and then even mathematically, there are problems because most biomolecules, at least proteins and nucleic acids like DNA and RNA, are information-containing molecules that have their function determined by specific sequences of subunit molecules that build these proteins and build DNA and RNA, and you can calculate the probability of sequences coming into existence that would be functional.
Right.
And those probabilities are super astronomical. The probability, the best calculation I've ever seen to produce a protein of about 110 amino acids in length says the probability is on the order of 1 chance in 10 to the 75.
Right.
But we realize there's only 10 to the 80 atoms in the universe, so your probabilities are astronomical and in some cases super astronomical.
Right.
When you think about all the proteins that have to come together simultaneously.
The universe is not big enough and is not old enough to accommodate those kinds of improbabilities.
Right, so there's just an enormous amount of data that's ignored in the face of the conclusion, or at least the desired conclusion, that life arose through natural processes. So again, worldview thinking is driving a conclusion and is forcing the avoidance of data or
well, one example of avoidance of data that is relatively recent in the origin of life camp is this recognition that RNA molecules aren't very stable outside the cell. And some researchers, I think it was Niles Eldredge, who made the comment that therefore the origin of life must be instantaneous, because we know that these RNA molecules simply aren't stable for a very long period of time. Even the building blocks of the RNA molecules, the nucleotides, are highly unstable outside the protection of the cell wall. Yet, is it reasonable from a mathematical perspective that you could get something so complicated arising virtually instantaneously?
Well, if there is this suppression of evidence, which, by the way, is a logical fallacy, suppressing evidence that goes against your view is just inappropriate. How do the naturalists sidestep this data? What responses do they make?
Well, we have a graphic that kind of summarizes the way in which Darwinists get around the evidence. And we're going to kind of bring this back now to the question of biological evolution as we look at this graphic. But as evolutionary biologists are confronted with evidence that runs counter to natural process biological evolution, they argue, well, the data is incomplete. The fossil record is incomplete. Or we don't know what's going on now, but if we wait long enough, we'll make the discoveries that will bring everything into focus, that will crystallize our understanding. And they also point out that, hey, this may not be a good model, but there are no other models that could explain life throughout the Earth's history. And so therefore, we're stuck with a poor model, but there's nothing out there that's any better.
That's a very common appeal, Ken, where they'll just say, well, there is no other model, and therefore this has got to be the way to go. And in one respect, they're right. There is no other naturalistic model for the origin of life. There's supernaturalistic models, but there's no other naturalistic model. And I would have to agree with these scientists. This really is the best you can come up with from a naturalistic perspective. But given how poorly it explains the circumstances, then we have to question, is a naturalistic model a reasonable explanation of what we're seeing here?
And as, I'm sorry, Ken, go ahead.
I was just going to comment briefly about this appealing to the future. We don't know how it works now. There is a fallacy that comes from the Latin, the ad futura, which says, well, we don't know how it works now, but we will in the future. Well, we don't live in the future. We live now. Give me an argument now. Provide an explanation. Sometimes when I interact with people who have a UFO worldview, they'll say, well, we don't know how these crafts get here now, but in the future we will. Well, we don't live in the future. We live in the now, and you have to make your hypothesis reasonable right now.
And I also see in that appeal an improper concession, What these people are really saying is that science is impotent to deal with it now. Therefore, we have to wait to the distant future for science to gain enough power. And I think that's simply incorrect. Science is not that impotent. It does have power, and we can exploit that power to expose whether or not the data really is missing, or whether that data exists. And in some respects, I'm willing to go a little bit into the future. 6 weeks from now, there's going to be a lot of new articles published in the scientific literature, and these articles are going to deal with these subjects. And we can look at these emerging discoveries over the next, say, 6 weeks to put this to the test. And so we don't have to wait 600 years. 6 weeks is enough.
Well, research in Darwinian evolution has been going on, and even non-Darwinian evolution for that matter, has been going on for easily 150 years.
Right.
And we know that scientific knowledge is accruing at exponential rates. I mean, there's so many articles published in the scientific literature, it's impossible to manage it at all. And it's hard to say that 150 years of research has left us with inability to understand, in essence, the physical nature of the universe.
What we already have in the way of scientific knowledge is more than adequate to determine these worldview conflicts.
Yeah, I mean, with all this, the papers that are being published, what strikes me is, sure, there are breakthroughs, sure, there are unexpected results, but these results are not changing our physical understanding of reality.
That's correct.
And so to appeal to the future is really an inappropriate appeal, and there's nothing that's leading me to think that there's going to be this breakthrough that somehow overturns our understanding of natural process evolution.
Let me give an extreme example. You got the Flat Earth Society claiming that the world is flat, and to support that paradigm, they're obviously avoiding a lot of data. And they're claiming, well, gee, all we got to do is wait for future scientific discoveries, and we're going to discover that Einstein and Newton and all the rest of those characters were wrong. They're appealing to the future in one sense for a radical revolution in science. But that's not going to happen. We already have overwhelming evidence that the world is not flat, that it's roughly spherical in shape. And there isn't going to be any future scientific discovery that's ever going to disturb that. And science proceeds along these lines of what they call the laws of physics. When we talk about a law of physics or principle of physics, it's something that we comprehend where the evidence is so comprehensive and overwhelming that we no longer dispute whether or not gravity caused apples to fall towards the center of the earth. That's beyond question. And then there are these theories which are also well developed on their ways to becoming laws, where we have lots of evidence that this is true. And then finally we got hypotheses, where we think this is a good explanation, but we don't have the evidence yet to say for sure that this is a correct interpretation of reality.
Well, when we look at this concept of how our worldview affects how we do science, are we enslaved to our basic foundational views? Is the naturalist enslaved to his material view? Is a Christian enslaved to their position? Is there any way to reel back in our views, to test them?
Well, I'll put it in a theological perspective. Romans chapter 1 tells us that when we rebel against the authority of God, we suppress the truth. And so in that sense, we are all enslaved, at least to some degree. Our natural rebellious nature towards God's authority will cause us to suppress data, to suppress the truth. But are we doomed to be permanently enslaved by that? I don't think so. But as you pointed out to us, Ken, worldviews can be very strongly entrenched. And it's going to take considerable effort to overthrow these worldviews because of the degree to which people are suppressing
Well,
the
to go
truth.
from one worldview to another worldview is in essence a conversion.
Right.
Where you are essentially replacing your understanding of reality with a new understanding of reality. And that requires a lot of facts pointing to the understanding that your current perception of reality simply is not right. And that the other perception of reality explains the data better.
So in that sense, it's really worthwhile to expose people to the evidence. If they see the evidence accumulating to a sufficient degree, that may motivate them to abandon their worldview and adopt another worldview. But one of my concerns is they'll jump from one worldview where they say the data doesn't support it to another worldview, and they lock in again to the suppression of the truth. Regardless of a worldview, we need to be constantly putting it to the test. I have my foundational beliefs that govern my worldview, but I should never lock that into concrete. I always need to be open to the fact that there will be evidences I haven't considered. I need to throw that into the mix. And my worldview isn't perfectly developed anyway. I need to be prepared to make adjustments. And I think that's what's going to deliver us from this hostile attitude in debating creation evolution issues, and really reason together with ourselves and with God and come to a knowledge of the truth. Thank you. Welcome to Reasons to Believe, the television program where we are looking at new reasons to believe in the God of the Bible, the accuracy and the reliability of the words of the Bible, looking at the frontiers of scientific discovery for new evidences for the Christian faith. And we're taking a little bit of a diversion from our usual program sequence of looking at, say, the past week's scientific discoveries and trying to put it in a Christian context. We're doing a few episodes on how to think about and analyze creation evolution issues and controversies. I mean, from our perspective at Reasons to Believe, these are arenas where Christians and non-Christians get into needless hostility and heated debate. And so we're trying to help you, the viewer, to really appreciate some good ways to ask questions if you're a non-expert. If you are an expert, how to work to bring about resolution in a way that helps people pass their anti-Christian or non-Christian worldviews. Incidentally, if you like this program, we encourage you to write in and thank TBN for keeping us on the air. They appreciate hearing from you, and we appreciate hearing from you too, because the suggestions you send in really help us in building episodes, building future episodes. So please communicate with TBN and with us too. And if you got questions of a scientific or a biblical nature, we have people here who can answer to the questions for you. Now, we're at that point in our discussion here on how to think about creation evolution issues. We're past that point where people say, well, this isn't even testable, it's not science, and we've been talking about how it's eminently testable. But I want to get into the hows in this episode. How do we go about putting creation evolution hypotheses and theories to the test? How do we confirm them? How do we falsify them? Ken, you're usually our point man to get us started, so I'm going to...
Yeah, I think that what we want to look at, and we touched upon this in the last episode, is what would have to happen for evolution to be true? I mean, what kinds of things, Fuzz, would we have to establish for evolution to be true? And why is it that, as creationists, why is it that we challenge these kinds of issues?
Well, let me get a little more specific before Fuzz answers. Let's take an example. Charles Darwin's descent with modification,
right,
which is the heart of the biological evolutionary paradigm, and even non-Darwinists, coming from a naturalist perspective, take this approach. How do we go about confirming or falsifying this concept of descent with modification? And Fuzz, can you begin by defining for us what Charles Darwin meant by descent with modification?
Sure. What Darwin noticed is that there's a variation that occurs within a population, and that that variation is inheritable from generation to generation. Mm-hmm. And certain trait combinations impart increased survivability and increased reproductive success, and therefore, if selection chooses those trait combinations, they will be inherited by the next generation at a higher proportion than in the previous generation. And over long periods of time, there's this gradual change that can occur within a species, and a new species can emerge from a parent species.
Okay, that's descent with modification. Now, how do we go about confirming whether that is a correct interpretation of the fossil record, the record of life on history of life on planet Earth?
Well,
or how do we go about falsifying it?
Sure. Last time we mentioned that there's a set of criteria that we could use to affirm or to refute natural process biological evolution, and that is to identify a mechanism, to show that that mechanism can generate the change that is needed, that the mechanism can operate under the conditions available to it, in the time available to it, and real-time verification of that mechanism or verification in the fossil record. And so if biological evolution is true, then there's certain collection of observations that we should be able to make from the record of nature to demonstrate its validity or to refute its validity.
Right.
And we have a graphic, I think, that shows some of those items that we need to demonstrate if we're going to show that evolution is indeed a fact. Evolutionists need the data to show verifiable evolutionary pathways, the existence of prebiotic life on the early Earth, gradual appearance of organisms in the fossil record, and an abundance of transitional forms.
Or intermediate forms. So, well, Fuzz, you're talking about how the heart of a good model for the history of life on planet Earth, descent with modification, depends on the mechanism. The idea that there's modification going on is something that all creationists accept, all evolutionists accept. The big question is, what is the mechanism? And when Charles Darwin came up with his origin of the thesis, it was of the species, it was natural selection. This is the mechanism that's producing the changes that we observe. And it wasn't very long before biologists realized that natural selection was a rather impotent mechanism to generate the changes we observe. And then thanks to Mendelism, they realized, wow, we got another tool. There are mutations that take place in the genetic code, and the combination of natural selection mutations will explain the history of life on planet Earth. But once they explored the fossil record to a little more depth, biologists and paleontologists recognize that the combination of those two mechanisms still will not produce the results that we observe. And then you got Niles Eldredge and Stephen Gould saying, well, they're episodes of hypermutation, where we got an extremely abundant amount of mutations taking place in a short period of time. This explains the jumps that we see in the fossil record. Well, we've argued before in the show that just simply throwing in extra mutations really does not help the situation. It brings about extinctions rather than speciation events. And so it's now accepted by many biologists that these three mechanisms do not provide an adequate explanation. They explain some of the changes, but not all of the changes. And, a couple of episodes ago, we talked about all these books I have here on the table. You're proposing different ideas, interjecting new mechanisms to explain the changes. The Gaia hypothesis that Earth somehow is a goddess, and there's intelligence wrapped up within Mother Earth, and this is producing another mechanism to explain these changes. Or chaos theory, Stuart Kaufman and his Santa Fe Institute, that there's something within the mathematics of chaos theory that can generate these changes. And his latest book, Investigations, speaks about a fourth law of thermodynamics. And what's really happening is that we're recognizing that all of these different natural explanations, mechanisms to propose the explanation for the history of life on planet Earth, explain a very tiny amount of the changes we observe. We're still lacking a good explanation or a mechanism to explain the majority of the changes we see in the fossil record, the history of life on planet Earth. And what we're proposing is that missing mechanism is God. Throw God into it, and then suddenly we can make the whole thing work and we can explain all the changes. So it's not that we Christians are saying that the naturalists can't explain any of the changes, but they're not able to explain all the changes.
They've done a good job of explaining microevolutionary changes,
exactly,
but they can't explain the macroevolutionary changes.
Right.
And the fossil record as real-time verification showing an absence of verifiable evolutionary pathways, an absence of gradual transformations, the sudden appearance of new forms in the fossil record, the absence of transitional intermediates show that on a real-time verification or time-based verification standpoint, these mechanisms just simply don't work.
And I think what's making the debate a lot more hostile than otherwise would need to be is a lot of evolutionists have the idea that we evangelical Christians are saying their mechanisms are flat out wrong. And that's not what we're coming from at Reasons to Believe. It's not that these mechanisms are wrong or can't be confirmed or verified. They're inadequate. They're simply not up to the task of explaining the history of life on planet Earth.
But, many people think that as we introduce God to explain life's history throughout the Earth's history, that this is a no-no, I guess, in scientific investigation, that we can't introduce the supernatural within science. Does science require only natural explanations?
Right.
And it's this whole idea of methodological naturalism, where even if you believe in God, you conduct your scientific investigation as if God didn't exist, as if God didn't intervene in nature to bring about these changes.
Well, I think this is an important point you're making, Fuzz, is that a lot of evolutionists are not atheists, they're deists. They believe God has a role in explaining the scientific record, but they believe that role is limited to the origin of the universe, where God sets up all the mathematics, all the physics, and designs the physics and the chemistry and the math in such a way that there will be a natural outflow that explains the history of life on planet Earth. Or they'll make the comment that God somehow works behind the scenes and orchestrates the outcomes he wants through the laws of physics. So that would be kind of a methodological naturalism from a theistic or a deistic perspective. And I've met some evolutionists who say, well, I'm willing to also think that God may have supernaturally intervened for the origin of life. But from there on in, he uses the natural process. And it really comes down to a debate not whether or not it's total miraculous intervention or total naturalism, but to what degree or where do we have the natural process explaining everything, and where do we have supernatural intervention? And this kind of gets us into the common accusations that evolutionists throw at Christians. You guys are just sticking God in those gaps where you don't understand what's going on, the God of the gaps argument. But on this show, we've made the point, Ken, that the shoe fits the other way too. Often when the atheist is scrambling for an explanation, he will bring up the no God of the gaps. So,
right. Right.
And could we just help the viewer understand what we mean by the God of the gaps and the no God of the gaps? Why don't I have you define for us the God of the gaps, and Ken, the no God of the gaps? Because I think this is critical, that the debate is heated because everybody is saying, where you don't understand, where there are gaps in our knowledge, where there's ignorance, that's where you're throwing in your biased paradigm. And how do we deal with that?
Well, the God of the gaps, as you've alluded to, is simply the accusation that Christians, whenever they encounter a discontinuity in nature, they don't look to fill that discontinuity in with new discoveries and newly discovered mechanisms, but rather they appeal to God's intervention at that point.
Right. Well, let me give you an example I think is easy to understand. Centuries ago, we had astronomers trying to figure out the orbits of the planets. And there were certain Christians who said, well, what happens is that God is there moving the planets through supernatural intervention so they take the paths that they take. And the reason they don't orbit around the sun in these perfect circles is because God is supernaturally intervening. And then with the invention of Newtonian mechanics and calculus, we understand, well, no, we can really explain the orbits of the planets without having God supernaturally intervene. And so scientists today will go into this arena of biological evolution and say, you Christians in the past made a mistake. I think it's important that we admit that Christians in the past did make a mistake. They tried to explain this problem that they couldn't understand by saying God supernaturally intervened. But I think where the evolutionists are incorrect is they're thinking that this applies universally. That whenever there is a region where we don't understand things, there will be a natural explanation. In that sense, Ken, we got the no God of the gaps. It's the assumption.
Yeah, we have gaps in our knowledge, and just as over-enthusiastic and Christians who may make a misjudgment and assert God, atheists, naturalists have a tendency, when they have gaps in their knowledge, to assert that, well, we don't know how it works now, but we will later. It'll all work out in the end. And so they're asserting they're no God of the gaps at that point.
Right.
And neither one of these, I think, is the way we want to really
Proceed.
work through the system.
Right.
When it comes to gaps in our knowledge, I like to think of the gaps as being three types. There is what I'll call apparent gaps. These are gaps that, as we do more investigation, we actually fill those gaps in. And then there's what I like to call inherent gaps in our knowledge, like the Heisenberg uncertainty principle. We can't know the momentum and the position of a subatomic particle exactly.
Right.
There's a trade-off in our knowledge. That's an inherent gap that we've discovered through science. And then there's what I like to call true gaps or discontinuities. And science is actually very good at discovering discontinuities in nature. I think of phase transitions when, for example, a solid goes to a liquid.
Right.
At the melting temperature, the heat capacity of the system becomes infinite. This is a discontinuity in nature. You could look at this as being a gap, if you will. And so science has the tools to distinguish between the different types of gaps. And so as Christians, if we posit that we expect to see a true gap here in the record of nature that reflects God's intervention, science does possess the tools to characterize if it is a true gap or an apparent gap through additional investigation.
Well, a good question a layperson could ask is, all right, you say there's a gap here, it's a God of the gaps or the no God of the gaps. Please tell me what kind of gap it is. And I think you've laid out three possibilities. And just knowing what kind of gap we're dealing with tells us how we can proceed to test whether a natural explanation will fill the gap or a supernatural explanation.
And I think we need to say something again about this methodological naturalism, this view that science is going to operate and only take into account natural causes. Now, if you take a hard form of that, that would run into problems with the Christian worldview, because Christianity says that yes, God made the physical world. We can discover truth from nature. But God has also revealed himself in his Word. And those truths need to be taken into account. In fact, Scripture says that the Scriptures will help us to interpret and understand the natural order. How do you as scientists respond to that hard naturalism, which I would think kind of bumps up against your Christianity?
Well, when you do run into gaps of understanding or gaps of knowledge where you just don't have the measurements, where there's a possibility of probing that gap, and a lot of the gaps that's the case. It's not like the Heisenberg uncertainty principle. We know that in the future we're going to have a more complete fossil record than we do today. We know in astronomy we're going to have a more complete record of the dynamics of the galaxies in the future than we do today. We don't know what's going on now, but we will know shortly in the future. Now, you could have two or more explanations of what's going on in that gap. Supernatural intervention or naturalistic causes or some combination of the two. Well, based on what you presume, you can predict what scientists will discover as they begin to probe that gap. And so there's a way to put this God of the gaps or the no God of the gaps to the test. To take an obvious example, we have within astronomy what we call the anthropic principle. That as we look at the universe, it has these characteristics that demonstrate it's been fine-tuned or designed to make life possible, human life in particular. Now, naturalists will say, well, that's simply apparent design. When we observe the universe in more detail, we're going to discover that there are natural explanations for why it seems to have these characteristics. The Christian will come in and say, no, it's real. And as we learn more, we're going to discover even greater evidence that this is fine-tuned in a way that shows intelligent design. And not just any old kind of intelligent design, the intelligent design we would expect from a Christian creator. And so as we probe those gaps, we can use these kinds of predictions to determine what the causal agent really is all about.
One of the concerns I think many scientists have as they embrace this hard methodological naturalism is that science doesn't have the tools to detect whether or not the supernatural exists and detect the intervention of the supernatural in the natural realm. But really, again, this is misunderstanding what science is very good at doing.
Right.
Because I would argue to detect God's supernatural activity, we need to be able to show that we can detect unobservables and detect intelligent causation, and science is very good at doing both.
It is, but it's harder to do when you're looking at a complex subject matter. I don't see quite the hostility of debate, say, in the astronomical sciences, because there we're dealing with something that's orders of magnitude simpler than organisms on planet Earth. Well, with organisms on planet Earth, I mean, we don't even understand everything that enables the dynamics of the organism. Typically, all you're looking at is hard body parts, just the bones. And so we don't have a good enough knowledge of the database. We're dealing with something that's orders of magnitude more complicated than simple stars. And therefore, there's a lot more discomfort on the part of the scientists to really make these kinds of tests.
Yet, and I would agree with what you're saying, that the complexity of biological systems makes this far more difficult, because clearly in physics, we readily detect unobservables like subatomic particles and forces and fields. And so I would argue that by extrapolation, we should be able to detect God's intervention by looking at macroscopic effects that we see in nature indicating God's work, just as we see macroscopic effects that can only be explained if we have subatomic particles and forces and fields.
Right.
But when it comes to intelligent causation, even in complex sciences and complex systems, we do see evidence for intelligent activity. We talked a few episodes about forensic science,
right,
where you're detecting intelligent causation. And that's a complex system. And also the search for extraterrestrial intelligence, or archaeology, or anthropology. These are areas where they're complex systems, but we can detect the operation of intelligent activity. So science does possess the tools to, in principle, detect whether or not God is at work in nature.
Well, a pessimist would look at biology and say it's too complicated for us to really make any headway on whether the causes are natural or supernatural. The optimist would say, well, in biology, we have systems that are orders of magnitude more complex and information laden than we do in the simple sciences of physics, chemistry, and astronomy. And therefore, there's the expectation we'll find much more evidence for supernatural intervention there than we would in astronomy. But the scientist is going to have to work harder. And who likes to work harder?
That's right.
So,
Fuzz, you've talked about in the past what you would call soft methodological naturalism. What is that about? Are you accepting some kind of methodological naturalism?
I think as an honest scientist, when you investigate a new system, you have to start off with the assumption that you can explain the system in principle through natural explanations, through natural mechanisms. And only as the data emerges that takes you to the direction that indicates the supernatural, do you then go down that route. So I think that's the proper way to handle scientific investigation from a soft methodological naturalistic point. Because if, and I think scientists who are concerned about the appeal to God too quickly have a good point, because if every time we see something that becomes difficult to explain, we immediately evoke the Creator, we're never going to discover anything. But we've got to, through experimental work, through observation, as the database emerges that takes us in the direction of the supernatural, it's only then that we go in that direction. We let the data lead our investigation, and we let the data help determine how we're going to explain the system. We don't make any type of presupposition going into the investigation.
but from a Christian perspective, there's going to be a degree of the softness of your naturalistic methodology. I mean, there are some Christians that would take the position that God intervenes much more frequently than other Christians would. And this is what's exciting to me, is we can not only determine that it's the God of the Bible behind this, we can determine the degree to which He is behind it. And this helps us fine-tune our creation models, both biblical and scientific. So it's not just a debate between soft and hard methodological naturalism, it's a debate between, well, how soft is this?
Right.
So,
well, in Genesis 1, there are a whole litany of different Hebrew verbs that are used to describe God's creative activity, some that imply superseding the laws of physics, some that in which God works within the laws of physics,
right,
some in which God lets the laws of nature run their own course.
right.
So there are, even Genesis 1 tells us that we should expect God to work in different ways under different circumstances.
Well, in our creation model, that's exactly what happens, is the softness varies depending on the subject matter at hand. So, well, what I'd like to do is kind of shift gears here and try to answer some of the common fallacies that take place within the creation evolution debate. And we'll get into this in more detail in the next episode, but could we at least get started on this? I mean, one of the problems I see on both sides, the creationists and the evolutionists, is the selective use of data. And probably the most commonly understood one would be the whale and horse evolution. That's the one you hear on television all the time. This whole idea of the transitional forms for both the horses and the whales. You know, in what way are we selecting the data in such a way to make it seem like our evolutionary or creationist paradigm is correct and everybody else's is false?
Well, you know, when it comes to the selective use of evidence, so often evolutionary biologists will point to the whale series or to the horse series as evidence of transitional forms, but these are exceptionally good examples when most of the fossil record basically refutes the idea of gradual evolutionary transformations.
Right.
And so this is a case where, again, selective use of the evidence comes to play, where much of the fossil evidence is discounted as they're trying to develop evidence for biological evolution.
So they're picking those parts of the fossil record evidence that appear to best support the paradigm and ignoring all the places where it doesn't. But I would argue even in the case where it's really good, there's a problem of misselecting the data. I mean, why do we have this horse and whale transitional form evidence so high it is relative to the rest of the fossil record? And does that really support an evolutionary paradigm? Or maybe it better supports the creationist paradigm? We'll hit this subject in our next episode. Welcome to Reasons to Believe, the television program where we explore new reasons to believe in the God of the Bible and the accuracy and reliability of the words of the Bible, looking at the frontiers of scientific discovery and exploration for new evidences for the Christian faith. And we're in the middle of a series on how to think about and analyze creation evolution issues, how to bring about resolution in an arena where there's hostility and heat and dispute. And gentlemen, we're kind of looking in this episode at evolution, creation, and the scientific method, or I guess what we could call the biblical method, since that's where the scientific method comes from. But before we launch into that, I just want to remind all of you that are observing that we really do appreciate your comments. If you like this program, I'd encourage you to thank TBN for allowing us to remain on the air, and let them know what you like about the program. Let us know what you like about the program. If you got questions, we'd appreciate hearing the kinds of questions you have, and we'll try to get back to you with some decent answers. And we really do take into serious context suggestions that you raise for future episodes for this show. In fact, that's how this program got started. It's through the letters that we received from our constituents that we saw the need to develop this series and how to think about and analyze creation evolution issues. So thank you for writing. The scientific method as applies to creation evolution. Ken, you want to kick us off?
Well, I think when we talk about the scientific method, obviously we're looking at empirical data. We're looking at a method that attempts to verify and falsify. And of course, in terms of what we're talking about, the question is, how does that work in the context of evolution?
Right.
Well, you know, I think one question that we want to address out of the chute is, what exactly is the theory of evolution in terms of the nature of the scientific method and how science is done? Because I would maintain, to some degree, the theory of evolution really isn't a scientific theory, but rather it's a historical theory. When we think about the scientific method in practicing science, we'll call it, for lack of a better term, standard science. This is kind of what we all conceive of when we think about what a scientist does. He goes in and he measures initial conditions very carefully and designs experiments so he can control the variables,
right.
He can control the parameters, and he runs positive and negative controls and can measure the final conditions very carefully, and through this process develop law-like relationships or cause and effect relationships. And that's really kind of the goal of standard science. Mm-hmm. And I think what's important to realize is that many times the conclusions that are drawn from standard science are conclusions that logically flow from the nature of the experimental design and the nature of the data itself, or can be extended through mathematical treatment of the data and of the results. And this stands in contrast to historical science or historical investigation, where you're not really trying to understand law-like relationships, but rather a unique sequence of events that happened in the past. So you're trying to answer questions like what happened, why did it happen,
When did it happen?
when did it happen, and what
Where
order
did it happen?
Yeah,
Right.
what order did it happen in?
Right.
And what you do in these situations is you look at the data that you have on hand. Maybe you can go back to the fossil record, and you take the data at hand and you try to come up with a scenario that is consistent with the data. But
Right.
the point is that the scenario doesn't necessarily logically flow from the data, but rather you try to conceive of a scenario that can explain the data.
Right.
And so really the theory of evolution is not necessarily a logical outworking of the record of nature, but rather is a naturalistic scenario that attempts to account for the data. You know, what you do when you try to develop a historical model is very similar to what a crime scene investigator does at the crime scene. You know, he looks at the evidence at hand and tries to come up with a scenario, or actually a collection of scenarios that are consistent with that evidence, and then tries to further investigate to determine which of those scenarios becomes the lead explanation
Right.
by looking for more evidence, more clues.
And actually, that forensic science example, I think, has validity as an analogy in the sense that a good forensic scientist first tries to establish what happened to the victim, in what order, where, when did these events take place for the victim. Then having done all that, we'll go to the next step of saying, well, what is the cause behind all these events that took place? And in one sense, that often gets confused when people deal with biological evolution.
Right, so it's really not, in essence, a true scientific theory. It's a historical investigation. Now, it doesn't mean that
Which is still true science.
it's true science. It's not substandard. It's just that the nature of the questions are constrained by the process that you have to use to approach those questions.
And I think what's difficult in terms of the creation-evolution debate is that there is some experimental work done to support the biological evolutionary paradigm, and often the layperson gets the idea that's the predominant science behind here, things like the Miller-Urey experiment. We tend to think that's what's going on, but in fact that's just a tiny percentage
That's
of
right.
the science behind.
Now, Fuzz, if you would place the theory of evolution in historical science, would you place the whole discussion of origins, even creation, in historical science as well?
Oh, yeah. I mean, anything that deals with origins and natural history is
Okay.
going to be a historical science to some extent.
But there may be some experimentation today that may relate to the origin question.
Sure, because you go into the lab and as you establish law-like relationships or law-like phenomena, that then informs you as to what type of mechanisms may be possible to bring about natural process change. You know,
Yeah, I was going to give an example, namely the origin of life. That's something that happened 3.9 billion years ago. And we have tools where we can check the sequence of events that took place, how, when, where. But then if you draw the conclusion that this is something that happened naturalistically without a divine creator, if that's really the case, then we should be able to run an experiment in the lab where we duplicate the origin of life. And so this is an example where, yeah, you have historical science here, or what's been going on over the past several billion years. But given the explanation we put on it, we could draw the conclusion that this should be repeatable under laboratory experimental conditions. If it's not repeatable under laboratory conditions, then we need to question our naturalistic paradigm and say, you know, if it's supernatural, then obviously we're not going to be able to duplicate it in the lab. But if it's natural, we should.
but what happens with many scientists who study the question of origins, not just simply biological evolution, but anything dealing with origins, if they do not allow for supernatural explanations, what they've done now is restricted the class of scenarios that can account for the data.
And they restrict the science that can be applied to the data.
Right, and so, you know, it's kind of like back to this crime scene investigation, and you have this real kind of fun tongue-in-cheek story you tell about a crime scene investigator who finds a body but doesn't believe in murder.
Right.
And so he's going to come up with a class of explanations to account for the dead body that are exclusively natural causes. And what he's done now is restricted his ability to discover the truth.
Right.
And this is exactly what's going on with biological evolution. Only a certain class of scenarios is allowed. That class isn't mandated by the nature of the data necessarily, but it's a philosophical position that's brought to bear on the question.
Now, would archaeology relate to this whole question as well, in that you're looking at the ancient world, you're looking at the physical environment of the ancient world?
Well, forensic science, archaeology, those are two examples within the realm of respected scientific research where clearly non-naturalistic explanations are seriously taken into account. When scientists say, well, science only deals with naturalistic explanations, only with naturalistic causes. You Christians aren't allowed to bring the supernatural in because that takes you outside the boundaries of science. Well, we can dispute that and say, what about the archaeologists? The archaeologist looking for stones, say, in the southwest of North America, he would find these little things, and by looking carefully at the stone would say, wow, this is an arrowhead. Or might look at it and say, no, that's just a stone that's the product of erosion. It looks like an arrowhead, but it wasn't crafted to be an arrowhead. And then looking at the arrowhead might draw conclusions as to the sophistication, the tool-making capacity of ancient North American Indians, saying, well, this tribe was much more advanced in its capabilities than this other tribe based on these stone artifacts that we find. And what's really taking place here is you've got a scientist who's looking at a find in the natural realm and then saying, is this something that's a result of a natural process like erosion, an intelligent fashioning of the stone to make a tool? And what is the degree of the intelligence or the technological sophistication of that intelligent being that made the arrowhead? And so now we can go back to the rest of science and say, well, we routinely do this in forensic science, where the forensic scientist is trying to determine, did this individual die of natural causes? Was it suicide? Was it murder? And if it's murder, what kind of murder?
Now, Fuzz, when you contrast this historical science with standard science, does that mean that things that are derived through historical science are not going to have maybe the rigorous testing that standard science would give, or should we be more cautious about origins than we would be about something happening today?
I think definitely we should be a lot more cautious because, again, we don't have the advantage of being able to design an experiment with proper controls. We can't control the parameters and the variables in the experimental design. And so the conclusions that we draw are, again, not logical manifestations of the way we conducted the experiment. But still, we can affirm these scenarios. We can gather more data that continues to support a particular scenario. We can falsify scenarios. So there's ways to discover truth through this investigation. But, I think a key point is that the naturalistic framework for much of science excludes supernatural explanations. And so if those scenarios are not allowed, then we really are closing ourselves off to discovering potentially what actually may be the explanation for the origin of life or the origin of life's major groups.
And Ken, there are arenas within science where the historical science is considered to be more rigorous and credible and better established than, say, the experimental sciences. And let me give you an example. If you go back to that arrowhead example, if all you got is a single poorly dated arrowhead, then the conclusions you draw from that are going to be more tentative than if you're looking at 1 million arrowheads over a wide historical period and geographical arena.
I see.
With 1 million arrowheads of all different degrees of fashioning, you're going to be much more confident about attributing intelligent cause to the shape and function of those arrowheads. Likewise, when it comes to the stars, we have 10 billion trillion stars to observe. And so even though our science is limited to observing what's going on in these different stars. The fact that we have so many of them spanning such a broad period of history of the universe and locales within the universe gives us confidence that we really do have a rigorous scientific understanding of how a star forms, how it burns its fuel, how it ends its burning cycle, and what happens to it after it burns. We can see this stuff all around us. Whereas you would think that experimental science is superior, but sometimes your capacity to perform an experiment is quite limited.
We can't make the sun in the lab.
Well, right. I mean, you can't create a star in the lab. Well, you can create parts of a star in a lab. I mean, that's kind of what's happening in plasma physics. We're trying to duplicate in a small volume what's going on in the center of the sun. But sometimes when you're running these experiments, you're not able to put the kinds of controls on it that you would like. You can't always run a double-blind experiment. And you can't run the number of variables, or your instruments may not be very good in taking measurements. The error bars may be significant. And in science, when it comes to running experiments, we have what are called the random errors and then the instrumental errors. And random errors, you take a bunch of measurements, and because of noise in the instruments, you get a range of values for the data points that you're looking at. And so you try to figure out, well, what's the real measurement and what's the probability that you get a significant departure from the real answer. But then there's these instrumental errors where you recognize that maybe the instrument is putting in a secondary effect. And so a lot of science, experimental science, is simply trying to figure out where the instrumental problems lie. And often the instrumental errors or systematic errors can be much larger than the random errors. And so in that sense, you could have very extensive experimental results where you're doing these repeated experiments, but it might be very poor science because of the limitations of the measurements and the techniques that you're using. So it depends. It depends on the experiment. It depends on the quality of the observations.
Both of them have their own ways of verifying and falsifying.
Well, what really makes scientists more secure in their conclusions are where you're able to combine them both. Where you can take the experimental science and combine it with good observational or historical science. When you got that going for you, then that's, and of course if you got a bigger database, I mean, you're able to sample millions of different examples rather than just a few dozen.
Right. Well, I think that leads us to talk a little bit about maybe what some people would call the limitations of science. What can we know? What can we know for certain?
This is a common concern that many people have, is that there are limitations to science that prevent us from knowing anything at all, or knowing things with a high degree of certainty. In fact, we have a graphic that kind of lays out the concern before us.
Limitations of science. Scientists can't really know anything for certain. After all, their theories are always changing. I have some friends, Hugh, who say you push the Big Bang cosmology and Christianity too close together, and the problem is that someday Big Bang cosmology is going to be overturned and Christianity will look fallacious and untrue. I hear this all the time.
Well, there are certain arenas of science where the changes are truly revolutionary, but predominantly that's not the case in science. The changes are not revolutionary, they're fine-tuning. And so therefore I think it's important to make a distinction where in our scientific investigations are we simply fine-tuning previously established results and conclusions. And this is where you're making measurements, say, with twice the accuracy that you have in the past, but we really have a good handle on the phenomena and the causal agents behind that phenomena. Whereas in other arenas, you're into brand new territory. And there you would expect to come up with things that are truly revolutionary. But to give an example, when people say that science is always changing and we cannot trust any of the conclusions, like the Big Bang, for example, or the origin of life. Let me give you an example that I think anyone can understand. There was a time when people speculated that the world was flat. But then science advanced to a point where we realize that's not true. The Earth is spherical. And so we have this concept of a spherical Earth. But what has happened is we've gained the ability, geophysicists have gained the ability to measure the figure of the Earth, not to within a precision of, say, plus or minus a kilometer, but down to plus or minus a few feet. We discovered that the Earth really is an oblate spheroid, which means that the poles are slightly flattened. And so instead of it being a sphere, it's like it's flattened a little bit like this. Now, the flattening is very slight. It's so slight that when you look at the Earth from outer space, it still looks like a sphere. You have to measure it with great precision to see this slight flattening at the poles. And then the theoretical physicist comes in and says, I can explain to you why it has this slight flattening at the poles. It's because the Earth is rotating with 24 hours a day. And that rotation rate is high enough that it's going to bring about a slight flattening through the conservation of angular momentum to the shape of the planet. And the degree of flattening that we observe is consistent with what the theoretical physicists would predict from the laws of physics. And this is what really gives us science comfort that, hey, we're really on the right track. Our theoretical predictions are being borne out by the observations. So the theory and the experiments confirm one another. But now we've got instruments that are capable of measuring the shape of the Earth to better than plus or minus a centimeter. And these new instruments show us, well, it's not exactly an oblate spheroid. It's a slightly pear-shaped oblate spheroid. But no one's going to come out and say, well, wait a minute, I guess you guys had no idea what the shape of the Earth was after all. Or maybe we don't need to believe the fact that the Earth is spherical. No, these are fine-tunings. Moreover, I would expect that when we can make measurements of the shape of the Earth or plus or minus a millimeter, we're going to see it's not exactly a pear-shaped oblate spheroid. But again, we're not going to go back to the flat Earth idea of the Earth.
You know, what I think many people confuse is this idea of a scientific revolution actually overthrowing previously established ideas.
Like the Copernican revolution.
Yeah, but I'm thinking more like Newtonian mechanics. Many people say, well, Einstein's theory of general relativity has overthrown Newtonian mechanics, or quantum mechanics has overthrown Newtonian mechanics. Well, this really isn't true. What they've done is merely extended Newtonian mechanics into regimes where Newtonian mechanics breaks down. In the case of quantum mechanics in the subatomic realm, in the case of general relativity, it's with objects moving near the speed of light. And so what these ideas, although they're called revolutions in science because they lead to breakthroughs, they really have not overthrown Newtonian mechanics. And in fact, general relativity and quantum mechanics both reduced to Newtonian mechanics in the case of quantum mechanics when you move to a macroscopic realm. In the case of general relativity, when you begin to move away from the speed of light, the Newtonian equations essentially reduce from the equations of general relativity and from quantum mechanics. So it's not really a revolution in the sense that Newton was wrong. It's just that he didn't have the full picture. And so many times people think revolutions are actually more revolutionary than they really are.
Right.
Well, to give an example, special relativity fine-tunes Newtonian mechanics. And we have measurements that now show us the reliability of the theory of special relativity to 21 places of the decimal. So it's an incredible experimental confirmation of special relativity. But it wouldn't surprise me if we discover that there's a very tiny fine-tuning we might have to make to special relativity. And when we got instruments that can make measurements to 30 or 40 places of the decimal, we may discover some new physics. Not that it's going to overthrow special relativity or that special relativity overthrows Newtonian mechanics, but it's going to allow us to see things to a greater degree of detail than we have in the past. So yeah, I think you're right, Fuzz. There's a big misunderstanding between what qualifies as a revolution and what simply is a fine-tuned adjustment in the model. You know, to go back to your question about the Big Bang, there are lots of Big Bang models that astronomers are investigating right now, and they all have their slight differences, but they all have three things in common: that the universe is traceable back to a transcendent beginning, the universe is continuously expanding, and was hotter in the past than it was in the present. And if I could just add this, guys, it wasn't Einstein that stated this first. Bible authors like Job and Moses have been declaring that this is the condition of the universe. In fact, what really impressed me when I was 16 years of age, looking at the different religions of the world, the Bible was the only holy book that taught Big Bang cosmology. No other holy book taught. In fact, no philosopher or scientist or scholar dreamed of the concept until the 20th century. But we have Bible authors stating this for 3,400 years.
Things like the stretching out of the heavens.
Yeah, how God is continuously stretching out the heavens. How God alone stretches out the heavens. How he stretches out the heavens like you would stretch out the fabric of a tent, making the point that the universe has a surface that's being stretched out. In the beginning, God created the heavens and the earth. The world, the universe that we can detect was made from that which we cannot detect. Paul makes a comment about time at the beginning and how that time is consistent with the origin of the universe. And then how the laws of physics are constant throughout the creation. And with an expanding universe, that means the universe of the past was much hotter than the universe of the present. You know, given what the Bible says about how consistent the second law of thermodynamics has been operating.
Very good. Very good.
Well, why don't we bring this back to biological evolution and kind of pose the question, how can biological evolution or descent with modification be confirmed or falsified?
Very good.
Now, something that was helpful to me even before I joined Reasons to Believe, when I was part of the viewing audience watching the show, I remember an episode where you and Dr. Mark Clark were talking about biological evolution, and you provided a set of criteria that had to be satisfied for any type of natural process change. And this was
Right.
a mechanism has to exist, and that mechanism...
This applies to any scientific model or theory.
Yeah, the mechanism has to exist that can
Right.
explain the change. It has to operate under the conditions available to it, in the time available to it, and there needs to be some type of time-based verification, whether it's real time or, in the case of biological evolution, from the fossil record. And so if you can satisfy these criteria, then you can demonstrate Darwinian evolution or biological evolution through natural processes to be affirmed. And if you can't demonstrate this criteria, it's a way to falsify the idea.
And it's not just enough to verify that you can get the effects that are claimed. You have to verify that you can get enough of the effects in the given period of time and the geographical location. And so the fact that evolutionists can demonstrate, well, mutations happen, that doesn't solve the problem. They have to demonstrate that enough mutations happen, enough mutations that can produce the results, and then be able to demonstrate that we're getting adequate production. So this is really the way to bring this stuff to a critique. Well, we'll pick this up again with you next time. Keep watching us at Reasons to Believe. Welcome to Reasons to Believe, the television program where we explore new reasons to believe in the God of the Bible and the reliability and accuracy of the words of the Bible. And we've been going through a series on how to think about and analyze the creation-evolution issues, how to get around the hostility that exists in the debate and bring about resolution from a Christian perspective. And we're going to launch in. And by the way, those of you watching us, we really do appreciate your comments. If you enjoy the show, we would encourage you to thank TBN for putting us on the air. And if you've got suggestions on how we can make the show better, we'd really like to hear from you too. And if you've got questions, we have people that are ready to deal with your questions. And if you want to catch previous episodes, we have them all archived on our website at reasons.org. And this is about, what, episode 6 or 7 in a series we've been doing on how to think about and analyze creation-evolution issues. And today I think we've got something that's really critical for this whole issue, this whole idea of Darwinism and the problem of evil. How many, coming from a non-Christian perspective, look at what they perceive to be evil in the created realm as evidence that there can't possibly be a God behind it, and therefore it's got to be the Darwinist paradigm or some naturalistic explanation for life here on Earth.
Yeah, this is important because in the last few episodes we've been talking about the importance of philosophy in terms of shaping the way we would interpret the record of nature and how philosophy contributes to biological evolution as being a mainstream scientific idea. Well, there's also a theological component to embracing biological evolution as well as a philosophical component.
Right.
And as you've mentioned, the problem of evil is resolved in the naturalistic paradigm through biological evolution.
Apparently resolved.
Apparently resolved.
Right.
Yep.
I think what's interesting too is that for centuries, Christians and even people in other religions have argued that evidence of design is evidence for God. But here there's an interesting challenge, that there's a lack of design or a fracture or imperfection in design that's being raised. So this is an interesting challenge.
Right. That a perfect God will give perfect designs, and if we can find evidence for imperfect designs, and this proves that it's not the God of the Bible. That's kind of the reasoning it's taking on there.
But this is not really scientific evidence for biological evolution, but rather it's, again, a theological framing of what you think God would be like or how you think God should
Right.
create, as opposed to scientific evidence that supports biological evolution. So it's really theological evidence, not scientific evidence.
Right. What you've got are scientists and lay people saying, well, if I was God, I would do it this way. I wouldn't go through these machinations and these problems. So in one sense, it's ascribing evil intent to God and thinking we know better than God does. But really, a lot of it has to do with a misunderstanding of what the database is really telling us.
Right, and Ken, you mentioned this idea of poor designs or imperfections in nature that are commonly cited as evidence for biological evolution. And I think two classic examples of this are junk DNA and the panda's thumb. And we've got graphics
Right.
that kind of point out these different
I
imperfections
think
in nature.
philosophically what's taking place here is this idea that God doesn't make junk. Therefore, if we find junk, it can't be God. But if it's Darwinism, hey, that's chance process. We would expect junk from a Darwinian or naturalistic perspective.
Yeah, we have a graphic that kind of talks about junk DNA and gives just some summary points. And what junk DNA is making reference to is this recognition that in an organism, in a complex organism, anywhere from 30% to almost 100% of the organism's DNA can be non-coding. It doesn't code genetic information, and therefore evolutionary biologists claim that this has no function. It's junk DNA and must be produced by blind, random chemical and biochemical
Right.
and physical processes, and just simply goes along for the ride from generation to generation because it's physically attached to DNA that codes for useful proteins.
Right. So the presumption is if it's non-coding, it's junk. And if it's junk, it can't be from the hand of God.
Right, and in human beings, I think probably 95% of our genome, at least as we currently understand it, is made up of non-coding DNA.
Now, something that's relatively new in the literature, instead of calling it junk DNA, they call it quote junk, unquote junk. So there seems to be a growing recognition that it isn't quite as junky as we thought it was. Now, as our biochemist here, do you want to explain why it's not so junky?
Well, I mean, short of going into 2 or 3 programs discussing
Right.
discussing non-coding DNA, the trend line is in the last 5 years or so, discoveries that are ascribing clear function to this quote-unquote junk DNA. That even though it doesn't code for a particular protein product, it actually has some type of role inside the cell. One example is non-coding DNA forms a nuclear skeleton. Inside the cell, the DNA is housed in a spherical structure called the nucleus.
Right.
And it's very critical that the nuclear volume is maintained at a constant ratio relative to the overall volume of the cell.
Mm-hmm.
And the only way you can maintain a nuclear volume is through DNA serving as a scaffolding or as a skeletal role, maintaining the nuclear size. And so this non-coding DNA is critical in maintaining that nuclear volume at a just right level to maintain a proper ratio with the rest of the cell. So this is one example of ways in which this non-coding DNA actually plays a critical role in cell function.
And it may be a symptom, too, of an overuse of the computer analogy for DNA. I mean, a computer, you've got these linear sequences of binary code, but inside the cell, the information is carried through 3-dimensional structures. And so you need something to support that three-dimensional structure, which you don't need in the computer binary code. And therefore, this over-application of the computer computational analogy can get you into real trouble.
Right. And each time you pick up a biochemistry journal, more often than not, you're discovering or finding a new discovery, that is ascribing new function to non-coding DNA. So the trend line is, hey, we're discovering new function. So, one of the principles in terms of approaching so-called imperfections in nature is to recognize that many times what's being called an imperfection in nature is a system that is incredibly complicated, that's poorly understood. And as we understand the system better and better, what seems to be at one time an imperfection, now it turns out to be evidence for elegant design.
Well, that's a very good point you're drawing out there, Fuzz, is that a layman who doesn't have a lot of background in biochemistry or mathematics can ask good questions. Well, you're saying that this is junk, but how complex is this thing you're calling junk? And the scientist says, well, we really don't understand how complex it is yet, and why are you so willing to call it junk? Maybe we need to be a little more humble in our perspective here and recognize that this is something we don't fully understand yet. If it's something you do fully comprehend, then you might have a basis for saying, well, there's no purpose in this. It's junk. But if you don't understand it.
Well, something else, too, is that we also we would maintain that God creates things in a state of perfection or near perfection. But we also live in a universe that operates under the control of the second law of thermodynamics. Things tend towards decay. So from a biblical standpoint, it's not surprising that there are going to be some levels of imperfection in nature that are going to be true imperfections simply because things decay in nature.
So in that context, we're more decayed than, say, Adam and Eve.
Right.
God created Adam and Eve, but there's been a lot of decay that's crept into the human species and the human genome over the last many thousands of years. And so we're not in as good shape as, say, our forefathers were.
Right. So our genetic code is going to accumulate and it's going to accrue mutations with time. And that's going to essentially make biochemical function less efficient. But what's interesting to me as a biochemist is when you look at the way biochemical systems are structured, there's all these mechanisms that are built in that are designed strictly for the purpose of dampening the effects of mutation. So here's additional evidence for design, even in the face of this decay that's occurring at a biochemical level with time. We still see, for example, the genetic code is designed with a redundancy in it so that when mutations occur, a particular type of mutation called a substitution mutation, that mutation can occur in such a way that it has a neutral effect or a silent effect on the operation of biochemical systems.
For that reason alone, you want a lot of so-called junk DNA, just to give the organism the possibility of surviving a few mutations.
Right. It serves as a buffer for mutations.
Now, let me ask a question, Hugh. Does embracing the Christian worldview, the truth of the Christian faith, imply that everything in creation would have to be perfect? Or is there something about the Christian worldview that would suggest something different, such as what you were talking about?
Well, I think the latter, not the former. I mean, Fuzz has commented previously that what you see in biology, in fact, you see that in our own designs when we make things in the factory, are trade-offs. Is that you're looking for a very complex functioning system, and you can have it be very functional in this area, but to make it highly functional in that arena, then you have to make it less functional in another arena. It's kind of like the video games my kids play, where they come up with a superhero and it has all these properties, but when you have one property that's very high, like high speed, you have to throw off strength. I mean, just to take a sports example, the people that run the fastest aren't necessarily the ones that could lift the most weights. You have to trade off. If you want to be able to lift a lot of weights, you've got to be willing to sacrifice some speed. A marathoner has different muscles than, say, a sprinter. And there's trade-offs that one must make. Well, likewise, given the laws of physics, there's going to be trade-offs from the perspective of a creator.
And so if you're trying to design, if you will, the best possible athlete, he's not going to necessarily be the fastest or the strongest, but is going to be some combination of strength and speed. And that's going to achieve overall athletic optimality by intentionally introducing suboptimal designs.
Well, could God make a cat that runs faster than a cheetah? Yes, he could. But we would discover that that new cat wouldn't be as capable in being able to get its prey as a cheetah would be. The back of a cheetah, for example, has to have some significant trade-offs in order to make possible the speed of the cheetah, which limits the lifespan of the cheetah, limits the kind of prey it can get. So these are things that we would expect from a creation perspective. So we don't demand perfection across the board. But maybe what you're getting at, Ken, is a theological perspective. That we see in the Genesis creation account is not a declaration that God perfectly created, but that his creation is good and very good. And I think it's important in the creation evolution debate to make the point that God is really heading towards the perfect creation. This isn't the perfect creation. This is a creation that's perfect in the context of setting up the best possible platform for the conquest of sin. But with the conquest of sin, we can expect a creation order that really is perfect in all respects. But because of sin, what we have right now is a good creation, not a perfect creation. Although you could argue it's the best creation in the context of providing a vehicle for the rapid and efficient conquest of sin. And so there's a trade-off thing. I mean, from God's perspective, it's much more important to have a creation order that allows for an efficient conquest of sin than it is to have, say, human beings that are very strong physically, able to run at high speeds, able to go through computational mathematics at a very efficient rate. He's willing to trade away some of that in order to provide a better situation whereby we can be redeemed from sin. I've often made the point that the best evidence for design we see in this created order has to deal with how physics has been structured to help us deal with sin, rather than how physics is structured to make our life optimal.
Now, another example of an imperfection that's kind of a classic example is the panda's thumb, and I think we have a graphic showing the panda's thumb. And the panda doesn't have a true thumb, a true opposable thumb, but rather one of the wrist bones, the radial sesamoid bone, has been elongated to form a sixth digit, if you will, quote unquote, a sixth digit that the panda uses to help strip bamboo leaves off of bamboo shoots, which is the primary food that the panda ingests.
Right.
And so Stephen Jay Gould calls the panda's thumb a clumsy contraption, not an engineering marvel.
Right.
And points this out as being, again, an example where a chance mutation produced this odd structure that was just good enough to help the panda to survive, but really is not, again, anything that you would write home about if you were an engineer.
Right.
But what's interesting, again, here's a situation as we continue to learn more about the panda's hand, we discover other features, and a team of Japanese scientists studying the panda's hand in detail published a little letter in Nature a few years ago now,
Right.
actually pointing out that the panda's hand is indeed an engineering marvel. And they showed, through a detailed analysis of the panda's hand, how this radial sesamoid bone actually functions in conjunction with another bone that's elongated called the carpal accessory, so that the panda has a high degree of manual dexterity and can make certain hand movements that actually form a set of pinchers with these two bones. And so they're
Which is
describing,
critical for these bamboo leaf consumption.
right, and so by co-opting these wrist bones and making them into additional digits, if you will, that the panda can use, you have a hand that has an incredible degree of manual dexterity.
Now, Fuzz, you've written an article on this for Facts for Faith magazine. I believe we also did a television episode
That's right.
on the panda's
Yes.
thumb.
We did.
So that television episode is archived on our website, and people can get a back issue of the Facts for Faith magazine. It was a wonderful article you put
Well,
together,
thank you.
and it's got nice diagrams in it. But it's another example where you've got someone like Stephen Gould, with all of his fame, saying, here is a bad design, therefore Christianity is false, when in fact it's an animal that really hasn't been subjected to adequate anatomical study. And when that was done, we discovered that what we thought was a bad design really was an elegant design, given the challenges facing the panda bear.
Yeah, there was a paper just published a few months ago, in fact, where scientists were looking at why only 5 digits and not 6 digits in most mammals. And it turns out that if you have 6 digits, it's impossible to put the foot on the ground and bear weight.
Right.
So that 5 digits are optimal, a 6 digit is harmful. And so if a panda did indeed have a 6 digit or a true opposable thumb, it wouldn't be able to walk around.
Right.
So here you see even more evidence that's being uncovered showing just how good a design this really is.
And Fuzz, in our webcasts, actually just this last week, we did a webcast where some people were calling in with questions about human anatomical design. And I get this a lot, where evolutionists will say, well, look at the human body. You got this appendix that's useless, you got this tailbone that's useless, and all this junk we see in the human anatomy, the fact that we get flat feet easily, back troubles, and they use this as evidence that even in the context of God creating Adam and Eve, hey, looks like your Christian God didn't know what he was doing. Look at all this bad design in the human body. How do we respond to that? Without going into all the details we did in our radio
Well,
show.
again, things like the tailbone and the appendix actually turn out to have important function.
Right.
Again, it's another situation where as we learn more about the function of these structures, we see they're not leftovers of the evolutionary process, but actually important components in the human makeup.
Right.
And two, we pointed out that human beings abuse their body.
Right.
We don't take care of our body, and so if our body breaks down prematurely, is it God's fault or is it our fault for misusing what gifts we've been given?
So the person that complains of flat feet, we should say, well, how many hamburgers have you been consuming every day? Maybe there's a good reason why you got these flat feet that got nothing to do with God. So
right, and again, we pointed out that God is about accomplishing the conquest of evil, and if we were these immortal beings that had an excellent design, our weakness and our frailty would never come to light. It's through the fact that our body does decay that we recognize the need for a Savior and the transient nature of life here on earth and the temporal nature of life here on earth.
in that sense, we could argue that we were better designed in the past. I mean, from a biblical perspective, the first humans were living about 900 plus years apiece. And then in Genesis 6:3, God says, 6:2, pardon me, God says, oh, it is 6:3, sorry, that he's going to shorten our lifespan to a maximum of 120 years. And so something happened to our bodies. And you're right, there's a real purpose in us not living past 120 years. It's better for us not to live past 120 years. And it's better that our body decays a little bit over those 120 years. I like what Paul says in 2 Corinthians 4, how we can rejoice in the rotten decay of our bodies because it's so slow. It takes decades. But as we look at what God does at the spiritual level, through the baptism in the Holy Spirit, we are renewed day by day. And there's a lesson in that for us that's more important than just the simple breakdown of our human bodies. So,
now, another question that's kind of related to this whole imperfection in nature is the idea that we can't understand how a loving God could create Earth with carnivores, with predatory activity, with diseases, with pathogens, with parasites, viruses. Right. And again, this is misunderstanding the fact that, for example, carnivorous activity plays a critical role in God's creation, that it's part of God's natural order, that ecosystems will undergo catastrophic meltdown and simply can't be stable apart from carnivorous activity that controls the level of herbivores, which consume plants, which are the primary producers in the ecosystem.
When I first started dating my wife many years ago, one of the questions she threw to me is, Hugh, why did God make flies and mosquitoes? Again, from an individual's perspective, it's easy to look at flies and mosquitoes and say, there's nothing good about a fly or a mosquito. This was after she was hiking with me in a trail where there were just thousands of mosquitoes. What could possibly be the benefit of all these mosquitoes? And I hear scientists asking the same question about the AIDS virus. How can that be the product of a good creator? How do you respond to stuff like that?
Well, I mean, to some extent,
my wife wasn't prepared to continue dating me unless I had a good answer for that. So.
You must have had a good answer then.
Yeah, I had a good answer.
I never had to pass that type of test when I was dating. I just had to open up doors.
I see.
Well, something like the AIDS virus, and I want to say this with the highest degree of sensitivity, but in many respects, the AIDS virus is reflecting man's sin.
Yes.
That we're violating God's laws, God's prohibition on certain sexual practices and sexual promiscuity, and as a consequence, this virus is now introduced into the human population.
Yeah, the Bible warns us not to be indiscriminate about the mixing of warm body fluids. When you do that, that provides an ideal environment for the mutation of viruses.
So in a sense, God is letting, to some respects, nature run its course, and that
Sure.
mankind is suffering. But it's not to say that good things can't come out of somebody who has experienced AIDS and who's dying from AIDS, because again, it points out their weakness and their mortality.
Sure.
And through that experience, many people, I'm sure, have repented and have turned towards God. And so we would argue God is able to achieve a greater good out of what seems to be an unfortunate circumstance in their life.
Well, I think, too, as something as complex as, say, a virus, we need to ask the question, is there really some ultimate good in the existence of viruses that we don't fully understand? Fuzz, you and I have talked about how a lot of medical researchers are now beginning to appreciate that these predatory viruses that we human beings have to suffer, things like the common cold, may play a role in giving us greater protection against infection from cancer. And we don't know all the details in that, but the fact is that there may be a very good reason why we have to deal with a common cold. Other species of life don't deal with a common cold like we do. But we're the one species of life that's been engineered by God to the greatest degree, where we get to experience many more heartbeats in our life than other creatures of life that God has created, but that makes us more subject to, say, cancer risks. And maybe viruses play a role in helping us get ready for that. And by the way, I think the same thing applies to mosquitoes and flies. God did not create mosquitoes and flies to be global. It's we human beings that made them global. And so we put them in places where God never intended that they would be. But where God did create them, they did play a critical role in keeping the ecology in balance. In northern Canada, mosquitoes play a role in consuming fecal material from the rodents. If it wasn't for the mosquitoes, we'd have a problem there. Maybe that explains why the mosquitoes up there are so big. I don't know.
Kind of another question that often comes up when it comes to Darwinism and the question of evil is, does embracing biological evolution, does embracing Darwinism necessarily lead to social atrocities like Nazism and communism and Columbine? Maybe we see how Ken would respond to this question.
Well, I think it's an interesting attempted connection, and as both of you know, I'm very interested in World War II. My father was an infantry combat soldier. Hitler liked to quote Darwin a great deal about the survival of the fittest, the need to rid the world of those who were weak and who couldn't survive. I think, though, Fuzz, in a conversation you and I had, you brought up a very good point, and that is that most naturalists, evolutionary biologists, would be revolted by a Nazi approach to things like that, and that often they would affirm kind of an absolute ethic. And I guess my question, though, is do these naturalists, these evolutionists who live responsible, commendable lives, is that consistent with their worldview? I realize that a lot of evolutionists would condemn Hitler, but do they have a right to condemn Hitler given their worldview?
Given their worldview, right.
Right. How do you explain the fact that I would argue many evolutionary biologists are probably committed family members, yet sexual promiscuity would be a natural outworking of Darwinian evolution, where the goal is survival of the fittest and reproductive success. And so promiscuity is a way to achieve that, not fidelity within the marriage relationship. But I could point to almost every evolutionary biologist I know as a committed family man, who I would be surprised if they ever would have had an affair outside their relationship. So this inability to live consistently really challenges the validity of their worldview.
Well, this is one way to make progress on the creation-evolution debate, is just to challenge everyone who's participating. Are we being consistent with our worldviews? Well, we'll pick this up next time. Thank you. Welcome to Reasons to Believe, the television program where we explore new reasons to believe in the God of the Bible and the accuracy and reliability of the words of the Bible. examining the frontiers of scientific research for new discoveries, new evidences for the Christian faith. And we're taking a slight detour from our normal show where we look at the, say, last week's scientific discoveries, how they're providing new evidences for the Christian faith, to examine how to think and analyze creation evolution issues. And the reason we're doing this, on both the evolutionary side and the Christian side of this debate, there's a lot of needless hostility within the church, outside the church, inside the university campus, outside the university campus. A lot of it stemming from the fact that people simply haven't been equipped on how to think about and analyze these kinds of issues. So that's what we're doing here. And if you enjoy what you've been watching, I'd encourage you to write TBN and let them know why you enjoy watching Reasons to Believe. If you've got suggestions for us on how to improve the program, we'd appreciate hearing from you about that as well. So keep those letters coming. And we're right now kind of looking at how to deal with some of the common fallacies within the creation evolution debate. Again, this is a big stumbling block for people being able to think their way through these creation evolution issues. Ken, you love to talk about logical fallacies, but there's a different kind or set of fallacies that are taking place within the creation evolution debate. And then maybe it'd be good for us just to review what the major categories of fallacies are, and then we can go through them one at a time.
Yeah, I think we have a graphic here that that lists them. Common evolutionist arguments. One, it would be the selective use of evidence. Another is the ad hominem attacks, circular reasoning, and straw man. And
could you define what an ad hominem attack is and what a straw man is?
Sure.
I'm sure everybody's familiar with those two terms.
First of all, an ad hominem is where two people are arguing, Hugh, and let's say I present an argument to you, and instead of you responding to my argument, rather you attack my character. And your attempt there is to undermine my character and thus discredit my argument. But the fallacy is anything you said about my character is irrelevant to the argument at hand.
Right.
And so this fallacy is often committed. We often think that the people we disagree with, if they disagree with us, there must be something wrong with their character. But that's of course not true, and we should stay away from character attacks. We should stay on target with
So instead of
reason and
objectively
evidence.
looking at the evidences that are being presented, we attack the one that is presenting the evidence.
That's right, and therefore that attack is irrelevant.
Right. Now, what about a straw man?
Now, a straw man is where we misinterpret our opponent's argument and then attempt to knock down an argument that we have distorted or made look more extreme. Just as a straw man is easier to knock over than a real man, if I distort your argument, Hugh, and make it look more extreme, then I can pick it apart.
Right.
But again, the problem with the straw man is the same as the ad hominem in the sense that all of my criticisms of a straw argument are irrelevant to your real argument.
Right.
So both of these fallacies would come under what we call fallacies of relevance. Really, they're not relevant to the argument at hand.
Right. Right.
And maybe we could say something about the selective use of evidence. I think there is something about all of us as human beings that when we have an idea or an argument, we have a tendency to selectively choose the data that supports our argument and then to ignore the data that goes against it. I remember one time I decided I wanted to buy a car, and the fellow that I was dealing with, he said, well, you should think of leasing a car. And I thought, well, what are the advantages of that? He said, well, you won't have to put down as much money, and your payment will be less. But he didn't tell me that they would penalize me if I drove too many miles and I had a long commute. So I think he selectively chose not to tell me the things that went against that kind of thing.
Right.
I think that is easy to do, where I go to the Bible with my pet doctrine, and I'm only going to look at the passages that support my view. I'm going to ignore the ones that challenge it. And I know this goes on in every walk of life, And therefore, it goes on when we look at the creation-evolution issues.
So the idea, if we're trying to argue that biological evolution is true, that all the evidence from the record of nature has to consistently support the nature and on all the aspects of biological evolution. And as evolutionary biologists, or evolutionary biologists, can't selectively choose features from the record of nature to support their idea. They got to look at all the evidence, and all the evidence has to consistently support evolution.
But I think Ken makes a good point. It's a natural tendency within all of us to favor the evidences that support our pet theory or paradigm, and to give less weight to those that don't. You know, in science, we've got this thing called a weighted average. And what you do is you look at all these different measurements that are being made, and then you try to judge which are the measurements that have got the highest quality. In other words, they're done with the greatest precision or have the fewest instrumental problems. And so we'll give that measurement more weight than another measurement where we might think, well, there's some problems, it's not as accurate or as reliable. But one of the issues there is, are you really being objective in establishing which measurement deserves the higher weight? And maybe you're coloring the weights to favor the interpretation that you really like. And I think that's one of the reasons why this discipline of science is best done in an arena of competition, where you have all these different interpretations, different paradigms that are competing with one another. Because what I see, for example, in the Astronomical Journal, somebody will publish a result and there's this weighted average of what the expansion rate of the universe is, for example. Well, someone who doesn't like the value that was adopted by that investigative team will say, no, wait a minute, I dispute the weighting that you put on these measurements. And incidentally, there is a measurement over here you guys forgot to stick in your lists. And if we put that in, we get a different result. And the reason why we need that going on in scientific research is because of the fact it's so tempting for us as human beings to select the data. And sometimes it's quite subtle. All you do is drop one measurement. You say, well, I didn't really have a chance to exhaustively read the literature, or I didn't read that journal.
Right.
Or, I thought that the error on that measurement was more extreme, or I didn't really like the guy who did that measurement. I always weight his measurements lower than someone else's. And so, but by having competition, people are going to come in there and put your weights to the test and make sure you've got all the evidence.
And this comes down to intellectual integrity. If we see data in both directions, we may reserve judgment. We may have to say, you know what, I'm not sure about this. It may take more study. And I think we have a scale here that we can put up on screen that in looking at both sides of this scale, what evidence would maybe go on the right that supports my view? What counter evidence would go on the left that goes against it? And I think we also have a good example, Fuzz, of how this is done in terms of some of the evolutionary example of horses and whales.
One of the features of the fossil record that must be true if biological evolution is true is the existence of transitional forms linking one group to another group. And so the common examples that are cited, at least in textbooks, are the horse series and the whale series. In the case of the horse series, it's this dog-like animal that evolves to modern-day horse, allegedly simply by increasing in size, by changing the dental structure, by changing the foot structure. Everybody has seen the Eohippus evolution to modern-day horses. Also, now it's common is to cite the whale series, which shows this wolf-like animal, Pakicetus, evolving to form modern-day whales. And so these are cited as examples that show, oh yeah, evolution must be true, that we have this transitional series. But this is really selective use of the evidence, because these are rare examples in the fossil record that seem to show transitional series. On the other hand, when we look at the fossil record in its entirety, what we see is something very different. Namely that in most cases we see an absence of transitional intermediates. We see the sudden appearance of fully formed organisms virtually out of nowhere in the fossil record. We see an absence of gradual evolutionary transformation. So the hallmark features of the fossil record really argue against evolution, but what evolutionary biologists are able to do is choose very specific examples that they would then use to argue their case. And maybe there are other ways to explain these as anomalies as opposed to actually true evidence for transitional forms.
So with some selective sighting, the scale is tipped toward evolution.
Well, I'd like to point out there's a selective scaling going on in terms of the transitional form evidence for the whales and horses. I mean, what you're getting is they're selecting the hard body part evidence of the transitional form. In other words, the bones. What you're lacking are the soft body parts, the soft tissues, the lungs, the hearts, the livers, the kidneys. And, given that you lack that evidence, what does that really tell you about the nature of these so-called transitional forms? We talked a little bit about this in previous episodes, how sometimes you can look at the teeth of the whales and get an idea of what was going on in the kidneys and the liver. And this gives you some idea of what was taking place in the soft body parts, and what you discover is it gives you a completely different interpretation in the hard body parts too. And so does this really give you evidence for natural biological evolution?
And I think that when believer or non-believer uses selective evidence this way, that it succeeds in undermining their credibility.
Right, once it's exposed.
Once it's exposed, and I think that's where caution and care, and Scripture clearly teaches us to have intellectual integrity.
Right.
In this. I think we also have some discussion here of the ad hominem attack. And this is often done. I think we have a graphic here. The ad hominem, a homonym of course is Latin for man, so attack against the person or the man. Scientific research done by Christians cannot be trusted because they're motivated by religious concerns.
This is a quote from...
This is a quote from a book review written by an evolutionary biologist, Jerry Coyne, published in the journal Nature, April 12, 2001 issue.
And he's reviewing the book Icons of Evolution
by Jonathan Wells.
Right.
And so the thrust of his review is that this is not the critique of evolution that comes to us by way of Icons of Evolution is not valid because Jonathan Wells was motivated by religious reasons.
Well, we got a second part of this quote coming up, I think. So that
here we go.
There it is.
Creationists hide their own differences about issues such as the fossil record and the age of the earth. They pretend to be disinterested seekers after truth. They fail to do their own scientific research. And like Wells, Jonathan Wells, they avoid at all costs revealing their own theories about the history of life. Icons, which is again the book written by Jonathan Wells, Icons is exactly as even-handed and intellectually honest as one would expect from someone whose, quote, prayers convinced me I should devote my life to destroying Darwinism, quote, unquote.
Yeah, interesting quote.
Now, when we look at this, Hugh, that first part of the quote, that scientific research done by Christians can't be trusted because they're motivated by religious concerns. This is an ad hominem, because essentially what is happening here is you're saying you can't take his scientific research seriously because he's biased, he's prejudiced, it's being colored, and therefore he's not a reliable source. This, of course, is very problematic. A person could still come up with good scientific research even if he were biased. He could still, if the data is solid, even if he were biased, the data would still stand. And secondly, one could argue that everybody has some kind of concern. Everybody has some kind of bias or intent. And it's certainly true that there are times where non-theistic scientists would like to present things in such a way to support their view. So I don't know that having a deep conviction one way or another rules you out as long as you're trying to be fair and objective.
Well, the reason we put this up on the screen is an example of a subtle ad hominem.
Yes.
Where you have Jerry Coyne making the comment, well, you can't trust Jonathan Wells because he's religious and he's got these biases. But by saying nothing, what he's implying to the reader is, I, Jerry Coyne, am free of religious biases.
Yeah.
And he's trying to communicate by simply not stating it that, Jonathan Wells is guilty, I'm innocent. I'm not like this. And you wisely pointed out that that's not true of anyone. Jerry Coyne has got religious prejudices too. There are religious prejudices in favor of atheism, as opposed to the prejudices that Jonathan Wells had would be in favor of the existence of God.
But the way the ad hominem attack works in terms of bolstering the theory of evolution is that by pointing out the religious bias of those who are critiquing evolution, what evolutionary biologists are doing is avoiding responding head-on to the very real concerns and the very legitimate concerns, in my opinion, that Jonathan Wells raises in this book and that other Christians raise in response to the theory of evolution.
Well, didn't you tell us once, Ken, that if you can't win the debate on evidences, attack the debater?
Yeah, but that's, that it often comes out that way. If I can make you, if I can question your credibility by attacking your character, then many people will think I'm not going to listen to the data. But again, whether I have a vested interest in this, the real question is the data, the argument, the evidence. That's the real issue. And the ad hominem is a fallacy because everything you say about the character that diverts you from the argument or the data is irrelevant.
So if a policeman that has a real bad attitude writes me a traffic ticket, do I still have to pay the traffic fine?
That's right.
Okay.
Now, we also have another example of circular reasoning. And I'd like to say something about circular reasoning. In logic, circular reasoning is where you assume to be true what you should have proven to be true. That's that circular process. Instead of moving from my facts and my evidence and my reason to my conclusion, rather I start with my conclusion. And I read my conclusion into the facts and the data and the evidence. So it's kind of like a chain that, my company makes the best automobiles because I pay them a lot of money, and I pay them a lot of money because I make really great engines, and I make great engines because I'm the best car company. It's kind of a vicious cycle.
Right.
I assume rather than prove what I should have proven.
Well, Fuzz, how is this played out in the evolutionary camp?
Well, one common example that I'm aware of where you see this circular reasoning is in the phenomena of homology, and we have a slide that, not an overhead, but a visual aid that helps us to see what homology is. Homology is this phenomena in which organisms that are related to one another have a common design that is used to generate very different structures with different functions. And the example here is the vertebrate forelimb for the bat, the dolphin, and birds, which all have this architecture that starts with a humerus. It has a radius and ulna in the forearm region, carpals, which are the wrist bones, metacarpals, the hand bones, and then phalanges, which are the finger bones. And this design has been modified to carry out different functions and to establish different structures, but it's the same design. Now, this phenomena of homology was discovered by Sir Richard Owen, a great British anatomist and paleontologist, and his explanation for homology was that it was the result of this blueprint that existed in the mind of God that was then modified as God executed that blueprint in the natural realm. Now, this was an explanation that appealed to the supernatural and wasn't satisfying for materialists. And so part of the claim to fame of Darwinian evolution was that it explained homology, with it being descent with modification, where there was this ancestor that had this design as part of its forelimb that then was modified through the evolutionary process as that organism split in different directions with time. And so Darwinian evolution now is the explanation for homology. But what happens in modern day is that homology now is used as evidence to support biological evolution. So in other words, that which biological evolution sought to explain is now used as evidence to support biological evolution. So it's this circular reasoning. It's very subtle, but it's really false reasoning, and it's poor critical thinking.
Yeah, and how do you go about exposing that circular reasoning? I mean, I'm kind of thinking that, here's this evolutionist saying, I see this functional arm serving many different purposes in different species of life. Why would we get that kind of radiation if it's simply natural selection mutations? Or from the perspective of Richard Owen, I mean, why would a creator do it this way? And by asking good why questions, you can expose where there's circular reasoning and where there's not.
Yeah, where are my assumptions?
Right.
Where am I drawing my conclusions from rather than making basic assumptions?
Right.
Well, we also have a fourth fallacy called the straw man, which is again distorting or exaggerating your opponent's argument and then critiquing that distorted
Right.
argument. And again, this brings us back to intellectual integrity. I need to listen to what other people say. In fact, I try to make the practice when I'm debating or presenting argumentation to see if I can't repeat back to my opponent what his position is, to stay on the point, to be able to do that. And this happens all over the place. Again, non-theists do it to Christian theists. Christians do it to each other, where we distort each other's arguments. We don't take care in presenting the arguments. And not to pick on the young earth creationists per se, but young earth creationists will sometimes distort arguments, and we have to bring them back. And we need to do that very same thing. I think we have an example of the naturalists. A naturalist might say that Christianity teaches the earth is only 6,000 years old. All of this scientific evidence demonstrates that the earth is much older than that, billions of years old. So the conclusion that the naturalist draws is Christianity is false.
Right. That's a straw man, because who says that Christianity is founded on the idea that the earth and the universe are only thousands of years old?
That's right. And so, again, this is done in various elements. I think that demonstrates the need for integrity when we look at these issues, to be candid, to be honest with each other.
And sometimes this is done very blatantly and purposely. I mean, I've got a number of books in my office written by evolutionary biologists, and they keep going down this path. Well, Christianity is a belief that the earth and the universe are only thousands of years old, when they full well know that there are obvious examples of Christian leaders and organizations that would dispute that from the context of taking the Bible literally and consistently. But the reason they do that, it's so much easier to tear down the creationist model built on thousands of years than it
Right.
is to seriously deal with a biblical creationist model where we accept that the earth and the universe and life on the earth has been here for billions of years.
And so, Hugh, the straw man fallacy often is distorting an argument by making it seem more extreme.
Or more ridiculous.
And therefore, it's easy to just punch holes right through that thing. Now, it could also happen, though, unintentionally.
Right.
Maybe we're just a little sloppy in presenting someone's view.
Well, that's what I like about what you said earlier, that when you're dialoguing with someone who takes a different worldview perspective, it's a good idea to pose some questions to them. Can you clarify precisely what is your position or your interpretation on this issue? And when you have that person verbalize for you in their presence, in your presence, then you're much less likely to commit a straw man fallacy.
Yeah.
So I think it's good. Yeah, it's not always done intentionally or purposely.
Right.
Sometimes it's done in complete ignorance. And this is one of the things we do when we do these interviews with creationists and evolutionists that disagree with us. We take a good 30 minutes just to have them explain in their own words what their position is, and when we don't understand it, we ask them questions.
And I think, too, citing the best people who represent that position, citing them within context, not distorting their argument by taking it out of context. All of these things, I think as Christians, we need to realize that the Bible talks about moral principles that we follow, telling the truth, working hard, not distorting things, but there are also intellectual virtues, being fair, being even-handed, and presenting people's arguments accurately.
And we have to admit that a lot of Christians do this to the evolutionists.
Right.
They put
Right.
them in a straw man context, and I think it's really critical that we admit that there are different positions that evolutionists hold on the explanation for life on planet Earth, and that the popularity of these positions does change with respect to time.
Right. And thus we're drawn back to truth. We want to look at the data. We want to draw conclusions that flow from the data, the evidence, and the facts. We want to correct the mistakes that we make in reasoning. And there are times where we Christians, or times I've individually made mistakes. I've had to correct those mistakes.
Well, the Bible tells us love covers a multitude of sins. I mean, if we're charitable towards one another in these dialogues and debates, then I think we're going to make some headway. It's when people get into this hostile posturing where people simply aren't listening to one another and talking to one another. So debates aren't enough. We've really got to get into some serious dialogues here, and to be fair and charitable towards one another. And in that sense, I think we've got a good model from the Bible of the apostles. When they disagreed with one another, they did so in charity and love and gentleness. Thank you. Welcome to Reasons to Believe, the television episode or show where we look at the new reasons to believe in the God of the Bible and the reliability and accuracy of the words of the Bible, where we examine the frontiers of scientific research for new evidences for the Christian faith. If you enjoy these episodes, we encourage you to write the Trinity Broadcasting Network and let them know that you enjoy this program. Tell them why you enjoy it. Tell us why you enjoy it. Suggestions you might have for future episodes. In fact, this very series that we're doing on how to think about and analyze creation evolution issues is a direct response to the feedback we received from you through your letters. So please write us and let us know what you think. And I think we're going to try to wrap it up today, guys, with some discussion on, how can we look at creation evolution issues from an integrative perspective? I mean, this is really the hallmark of Reasons to Believe, an organization that looks at the whole of the revelation across the pages of the Bible, but also the whole of the scientific disciplines. So let's just spend some time examining how we can better integrate all the revelation that God has given us. He's given us 66 books, the Bible. He's also given us this vast record of nature. How can we integrate the two to better understand the truth that God wants to reveal to us?
And I think you're hitting upon a real important point, because many times when it comes to research in origins, when it comes to research in biological evolution, many times the research is done with hyper-specialization, and in the absence of full integration, a piece of data in a highly specialized sense seems to buttress the theory of evolution, when in fact, when you look at it in the larger context, you realize that it actually creates problems for the evolutionary paradigm.
Right, right.
I mean, one example where there's a lack of integration, and we've seen this firsthand, is origin of life research. And for example, origin of life research many times is done as research by chemists, or it's done with research by biologists or astronomers or geophysicists, when really in reality this discipline involves a combination of those disciplines, and all that understanding needs to come to bear on the problem.
That's a good point, Fuzz, because if you go back to the 50s, the origin of life was considered to be an exclusive discipline of chemistry. This is only something that concerned chemists. Then biologists jumped in and said, no, wait a minute, you're talking about the origin of life. Life is our property. And therefore it was seen as biochemistry, biology and chemistry being integrated together. But yeah, in the last Origin of Life conference that we attended, we saw the growing recognition within the Origin of Life research camp that it's more than just biology and chemistry. And to really do a decent job, you have to look at the geophysics of the Earth, what's happening with the history of the Earth. It becomes a planetary science endeavor. Well, what about the dynamics of the solar system? How does that play into the origin of life? Things like the faint sun paradox, where solar physics now becomes a critical feature in trying to understand the history of life on planet Earth, and even beyond that in terms of how do you have to structure the universe as a whole just to get the chemistry that's necessary for the origin of life?
Well, I think it's interesting because if you look at the history of the modern day origin of life research program, in the 50s, when it was conceived as a chemical problem, there was a tremendous amount of optimism as chemists were in the laboratory making amino acids and nucleotides and things like that. But as it's become more and more of an integrated discipline, what's being unearthed are increasing number of intractable problems for the naturalistic paradigm. But if the discipline is not done as an integrated science, then it seems as if there's greater evidence for the theoretical model than there actually is.
You're not going to really expose the intractable problems unless you do look at it from an interdisciplinary perspective. Or in the context of looking at the origin of life from a miraculous perspective, the intervention of the God of the Bible, you're not going to appreciate the depth of evidence in support of that model unless you really integrate. Look at all the disciplines of science. And for that matter, go throughout the entire Bible and see what it's got to say on the issue of the origin of life.
Yeah. I think we have a series of programs coming up in the near future where we're going to devote full attention to the origin of life question.
Right.
And we just did a series of episodes on who is Adam.
Right, the origin of man.
Origin of man. And that's another area in evolutionary biology in which it requires integration to fully appreciate the nature of the problem. And we have a graphic here that shows the different disciplines that feed into the origin of man question, from the fossil record, paleontology, archaeology, radiometric dating of the different geological layers where the bipedal primate fossils are found, anatomy plays a role, genomics. And so there's a wide range of disciplines. And again,
so it's no longer just paleontology.
No, it's no longer just paleontology. But when it was just paleontology, again, in isolation, that fossil evidence seemed to give greater support to biological evolution as an explanation for the origin of man than it does now when we look at the fossil evidence in light of a larger context and as an integrated discipline.
So integration is one of the ways you can more easily and exhaustively put the different paradigms to the test.
Yeah. Now, another area that is failed to integrate into biological evolution is mathematics. And many times evolutionary biologists simply ignore the mathematical problems in terms of probability of the evolutionary process generating new life forms or generating change among the different groups of organisms that we see on the Earth.
Right.
And I think we have a graphic that kind of highlights just some of the mathematical probabilities centered around the origin of life question, for example. This is something maybe you could take away, Hugh, since it deals with astronomy.
Well, sure. This is something we've been doing for the last several years, starting in my book, The Fingerprint of God, in 1989, up until the third edition of The Creator and the Cosmos, just published a few months ago, where what we've been doing is looking at emerging scientific discoveries about the solar system and the universe and asking the question, what is the probability of finding a planet like Earth that can support life? Not just life as we know it, but any kind of conceivable life that would fit within the laws of physics. And back in 1989, when I had the first edition of The Fingerprint of God out, we were looking at 22 different characteristics of the Earth, the Sun, and the solar system that we were aware of that needed to be fine-tuned to make life possible on planet Earth. Well, now we know a lot more about the solar system and the universe than we did back in 1989. So in this edition of The Creator and the Cosmos, the list adds up to 148 different characteristics of the universe that must be fine-tuned in order for life to be possible. And when you look at the fine-tuning, which we now have a greater handle on too, the numbers are a lot more reliably determined than they were back in 1989. The bottom line is the probability of finding a planet anywhere within the observable universe, assuming as many as 10 to the 22 planets exist, and we take into account the dependency factors that exist amongst these 148 different characteristics. Taking all that into account, we conservatively draw the conclusion there's less than one chance in 10 to the 186 of finding even one planet like the Earth that would have this capacity. Now, that tells us that there really isn't the remotest possibility from a naturalistic perspective that you're even going to find a place where life could exist anywhere in the universe apart from the miraculous intervention of God. It tells us that planet Earth is the product of the miraculous intervention of God. And the only way you're going to get another planet somewhere out there in the universe that has these characteristics is if God miraculously intervenes twice at a different location. Now, from a Christian perspective, that possibility exists, and so we have astronomers and reasons to believe who take the view God did it only once. We have others that take the view that God did it more than once. But we all agree it's not going to happen through a naturalistic, simply the random possibilities of finding a planet with the just right characteristics for life.
And we also see problems with probability of even the simplest bacteria coming into existence through chance processes. And we have, again, a continuation of this graphic that shows, based on a calculation done by biophysicist Harold Morowitz in the 1960s, in which he...
You know what's interesting about that, Fuzz? There was one conference where mathematicians and evolutionary biologists got together, a conference held in 1966. And it was at that conference that Harold Morowitz proposed this thought experiment. Want to tell us what the experiment was?
Yeah, what he did is basically assumed he could take a bacteria like E. coli, which is a common bacteria found in the human gut, and break every chemical bond in the bacteria, and then let those chemical bonds reform through random processes. And the probability of getting a bacterium was on the order of 1 chance in 10 to the 100 billionth power.
Right.
And so what it basically is saying is there's no way through chance processes that even the simplest life form could come together through random processes.
And that really is a conservative estimate, because Harold Morowitz was assuming that when you break all the chemical bonds, you let none of those chemicals escape the reassembly process, and you let no contaminants come in to disturb the reassembly process, and you keep the system under ideal conditions for chemical reassembly. Even then, you get these incredibly remote odds. And 1 chance in 10 to the 100 billion is hard for the lay person to conceive of. That's 100 billion zeros after the 1. It would take 25,000 complete Bibles to write that number out in longhand. I mean, it would fill a whole shelf or row, 25 feet long, 10 feet high with Bibles, to be able to write that number out longhand. And as you've pointed out, hey, there's only 10 of the 79 protons and neutrons in the entire observable universe. And in that context, Harold Morowitz would say this idea that these chemicals could come together under natural conditions to make the simplest life, there isn't the remotest possibility that this could be the case. So yeah, here we're seeing a need to really integrate the mathematics. Incidentally, there's never been a conference like that since. I think it was such a shock to the evolutionary biologists to see this small army of mathematicians, even in the context of what we knew in 1966, just demolish the Darwinian paradigm for the origin of life and the development of life, that there's never been a conference like it since.
Well, given these staggering improbabilities, I mean, how do naturalists respond to these odds?
Well, you've got people like Richard Dawkins. I've got one of his books here. It's called Climbing Mount Improbable. And in one sense, the very title of the book is encouraging, because these evolutionists are admitting that it is highly improbable. But what Richard Dawkins claims is we can get around the kinds of vast improbabilities that Harold Morowitz talks about and that I talk about if you assume that there's some mechanism within nature that allows you to hold things in memory. So basically, he gives the example, the idea that a bunch of monkeys typing on typewriters could produce a complete plays of William Shakespeare is impossible. It's just never going to happen. But he says, if we could have a monkey randomly typing on a typewriter, and he produces the first letter in the play Julius Caesar, for example, by William Shakespeare, and once he produces that first letter, we keep it in memory. Then we have the monkey work on the second letter. When it comes up with the right second letter, we have the monkey stop and we pull that letter and put it into memory. It says if we continue to do that, then these monkeys randomly typing on typewriters can easily produce the complete works of William Shakespeare. But the assumption is that there's some means within nature, not divine, miraculous, or intelligent design intervention whereby there's this memory system. And the critique is simply this: there is nothing within the natural record that indicates that there is a memory-keeping device. Moreover, we need to recognize that for this explanation of Richard Dawkins to be viable, you'd have to keep these information segments in memory for a very long period of time. And what he's really trying to deal with is, say, like the evolution of the eye or the evolution of a heart or a liver. Well, you have to pretty well put all the pieces together before it has any functionality. And how we do it in a factory, for example, is we put all the parts together that we need, and we hold them there for a while. It's the equivalent of putting them in memory. Then we step by step assemble them. But the individual components have no functionality until they're assembled step by step, which means somebody has got to remember that these different component parts are going to have future functionality. While natural selection and mutations are not mechanisms that can take advantage of holding things in memory.
Right.
What you have is a bunch of useless components that are just sitting there, draining the resources of the organism until some future point where they become functional.
Now
But it is a common way to deal with this so-called improbabilities.
Right. Well, in light of this, we have a film clip to kind of illustrate the staggering improbabilities that naturalists are faced with. So,
and a typical response that you see from naturalists.
that's right.
Okay, let's look at this clip.
I want to ask you a question straight out, flat out, and I want you to give me the honest answer. What do you think the chances are of a guy like you and a girl like me ending up together? What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of 1,000,000.
So you're telling me there's a chance? Yeah!
All right.
Kind of tongue-in-cheek, but honestly, I've seen that type of response. In addition to the response that Richard Dawkins would make to these types of improbabilities, I've seen some evolutionary biologists argue the law of large numbers, that sure, these probabilities are extremely remote, but given enough chances, given enough opportunities, given the size of the universe, given the age of the Earth, that's even the most improbable things still have a chance of happening.
Right. Well, for example, and I talked about this 1 chance in 10 to the 86 of finding a planet like Earth. Often the naturalists will say, well, hey, Dr. Ross, you're assuming we only have one universe to work with. What if we have an infinite number of universes? Then in that infinite number of universes, then we may have the possibility of a planet like Earth would have the capacity for life. That's how we got here, not because God created this universe or created planet Earth or designed it. It's just that there's simply an infinite number of universes, all with different characteristics. I won't take the time to go through this, but this is really a form of the gambler's fallacy, assuming the benefit of an infinite sample size when you have evidence for a much smaller sample size. And because of the theory of general relativity, we know if there's observers in universe A, and God somehow made 2 universes. Once you've got observers in universe A, the space-time envelope of that universe can never overlap the envelope or manifold of a second possibly existing universe, which means the sample size for those observers is 1. And therefore you need to develop your philosophical and theological conclusions from that context, not from the hypothetical infinite sample size that might conceivably exist. And probably one of the best ways to expose this is looking at gambling strategies, say in Las Vegas. You see a coin being flipped 100,000 times and it comes up heads all 100,000 times. Dare you bet tails on the 100,000th and first flip? I wouldn't do it without examining the property of the coin. Even if I felt the coin was a fair coin, and logic and rational good sense would tell me with 100,000 consecutive heads, that's not a fair coin. But even if I believed it was, before I would place my bet on tails, I would like to ask the flipper, can I please examine the coin? And if I see heads on both sides, I'm not going to bet tails. And in one sense, whether you're an evolutionist, a naturalist, a deist, a theist, a Christian, looking at these creation evolution debates, we all have the opportunity to pick up the coin and examine it in more detail. And if that examination of the coin in more detail shows that our model is false or is not comporting with the new data that we've just received, then logically we should reject that paradigm. And I think this is a problem when people see these improbabilities and they draw these ridiculous inferences. But the ridiculous inferences, if you don't believe they're ridiculous, can be still put to the test.
Well, too, I think sometimes there's a failure to really appreciate the fact that these probabilities are exponents.
Right.
And so when you go from 10 to the 50th to 10 to the 51st, you're increasing the probability or the improbability by a factor of 10.
Right.
And if you go from 51 to 52, now you've increased it by a factor of 100 from the original probability.
Right.
And so when you look at the probability of 1 chance in 10 to the 80th, if I'm not mistaken, that's from a statistical thermodynamics calculation, you can show that that's the likelihood of the second law of thermodynamics reversing itself.
Right.
And we know that that doesn't happen. So whenever we encounter probabilities on the order of 10 to the 80 or greater, we really are looking at essentially a zero probability.
Well, when I see people committing these fallacies within academia, that's often a good way to respond, saying, well, do you believe it's possible you could die 5 minutes from now from a sudden reversal of the second law of thermodynamics? And, typically the academic will say, well, no, that's utterly ridiculous. Well, are you aware that you're relying on probabilities that are even more remote than that and claiming that naturalism has a chance for explaining this phenomena we're seeing here? And so you're right, particularly in the biological sciences or the social sciences, there's a failure to appreciate just what these exponents really tell us about the improbabilities. These are not tiny numbers.
In bringing this series kind of full circle, I know that we also want to identify a number of arguments that Christians use against evolution that we think maybe are not so good. We've tried to talk about good ways of arguing against it, but are there things that Christians say about evolution that are maybe misguided?
Some really dumb ways to respond to the naturalist or the evolutionary paradigm. Yeah, we've got a little list here, and it's by no means complete, but these are some of the more common dumb responses by Christians to the evolutionary or naturalist paradigm. The first of these would be the idea, well, I mean, you weren't there. Christians will say that to the scientists. Well, you weren't even there to see the origin of life or to see the origin of the universe or the origin of humanity. How can you as a scientist make any kind of credible statements about this? And that's even a charge that's thrown against me. I was once involved in a debate on the age of the earth from a biblical perspective, and someone said, well, Hugh, you weren't even there. My response was, yes, I was. In astronomy, it takes time for the light to reach us into the telescope. And so did I see the origin of the universe? Well, I saw a lot of the origin of the universe. Just the fact that I can see these images of the cosmic background radiation means I'm directly witnessing what was happening in the universe when it was only 0.001% of its current age. So in that sense, we become a direct witness to what God was doing in creating the universe. That's just one example, but you can apply it to the origin of life, the origin of humanity, the origin of the dinosaurs, the extinction of the dinosaurs, etc. A second one we have here in the list, if evolution is true, then why are there monkeys still running around? Shouldn't they have evolved beyond that by now? Or another one could be using bacterium. If the first life form was this primitive bacterium, why do we still have primitive bacteria around? Fuzz, why is that a lousy argument?
Well, because the idea, according to the evolutionary model, humans and chimpanzees shared a common ancestor. And so people ask, well, why are there still chimpanzees then if humans evolved from chimpanzees?
Right.
And the key point is that no evolutionary biologist is saying we evolved from chimpanzees.
Right.
Rather, we shared a common ancestor that gave rise to separate lineages according to the evolutionary model,
right.
One that resulted in humans, one that resulted in chimpanzees.
And even if there were monkeys back then, this is not saying there isn't a room within the ecological niches for monkeys today. Or even from a creationist perspective, if God needed monkeys a few million years ago, that doesn't negate the fact that he might need monkeys today as well.
Yeah.
Same thing with the bacteria. We still need bacteria.
Right.
Hey, got a third one there,
Yeah,
Franz?
how about scientists are in collusion to twist the evidence and deceive Christians?
Christians and others.
Yeah,
Yes.
and others.
Right.
You know, and this again is attributing, I think, way more competence to evolutionary biologists or any scientist than is merited, because to pull off a collusion of that magnitude is just unbelievable.
So you're saying we scientists aren't smart enough and organized enough to be able to pull something like that off?
No, and as you've mentioned, and I would concur based on my experience, scientists are incredibly independent-minded, and so it's very difficult to get two scientists to agree on anything,
Right.
let alone pulling off a collusion.
Well, I remember my department chairman saying that science professors are like trying to herd cats. There's no way you can really organize them to do much of anything, let alone get into a collusion of that nature.
And I think it's offensive too, because what you're saying is that inherently evolutionary biologists are evil.
Right, they're evil and dishonest.
Evil and dishonest, and that really is highly offensive.
Right, especially when they're paid to educate. So,
Yeah.
Well, we got a fourth one here. Darwinism is wrong because it's promoted by atheistic scientists. Why is that a bad argument, Ken?
Well, the question is not who promotes it. The question is it true?
Right.
It's a matter of looking at the data and evaluating it. Just because a person happens not to believe in God doesn't rule out that a person may not have a good argument. So the issue is not what people believe. The issue is, are there good reasons for believing
Right.
the data?
I mean, this is a form of an ad hominem argument.
Yes.
And a fifth one, I think it's kind of common in the last few years, is that Darwinism is wrong because Darwin himself renounced it on his deathbed. There's this myth running around that Charles Darwin had a deathbed experience to the Christian faith. And while that may be possibly true, there is not one bit of evidence to in any way substantiate that claim. Who knows what happened to Charles Darwin on his deathbed? So I would say people who claim to remain an atheist to the end of his life, well, there's no evidence to prove that in any definitive way. Likewise, there's no evidence to prove that he had a deathbed conversion to the Christian faith. And Charles Darwin is just one example, because so often I hear Christians making the claim that scientist Joe Blow, and they'll pick someone who's really famous, has had this remarkable conversion. Then you check into it and discover, well, that's not really the case, whether it be alive or dead. And so that's, again, another example of a kind of a different way of putting the ad hominem argument.
You want to be careful in your
Right.
thinking.
And this is by no means exhaustive, but we really encourage you to do what you can to avoid the bad arguments for the Christian faith, especially when we have so many good ones. Thank you. Welcome to Reasons to Believe, the program where we explore new reasons to believe in the God of the Bible, Jesus Christ as our Creator, Savior, Redeemer, and new evidences for the accuracy and the reliability of the words of the Bible. And we're looking at a series of programs that deal with the issue of how to think about and how to analyze creation evolution issues. If you missed the previous episodes, I think there's been, 5 previous episodes. They're all archived on our website at reasons.org. So if you're just jumping into the middle of this, you can go to our website and either view or listen to the previous episodes. And this particular program, we want to look at how to interpret the data. Now, our whole point is that we're not questioning the data. We're not questioning the time scale for the data. These fossils are real. The dates on them are reasonably accurate. We're not questioning the data or the time scale, but we are questioning the interpretation of that data. So we want to spend a little bit of time looking at, how do you go about interpreting the data, interpreting the scientific record, the record of nature. And this all fits into worldviews. And Ken, you're a philosopher and theologian, so I'm going to ask you to kind of lead our discussion. And Fuzz, you're a biochemist, and I'm the astronomer, and the minister will jump in and try to flesh things out as we go on.
I think it's very important, first of all, to begin pointing out that there's really kind of a myth of neutrality that circulates around how people interpret data and evidence, and that nobody is completely neutral. We all have our biases.
So there's no such thing as an objective scientist?
Well, I think you have to work at being objective. I think you have to work at being fair-minded. I'm not suggesting that you can't come to a fair-minded approach of the facts and the data, but I think that what is part of being objective is admitting that we have foundational beliefs, presuppositions, our ideas that we have before we approach the data. We could speak of these in a negative term. We could talk about biases or even an agenda that someone could bring to these issues. And so what we're doing now is tying our foundational beliefs to how we approach the scientific data. And that's very critical because scientists, just like everybody else, bring those foundational beliefs to what they do, as philosophers do, as theologians, as everybody does.
But we can prevent this becoming pejorative or ad hominem, where people are calling one another names, if we simply encourage honesty. Here are my presuppositions,
Yes.
here are my biases, this is my worldview. Please tell me what your perspectives on this issue are. And if we all understand where we're coming from in terms of worldview or bias or perspective, it's really going to facilitate dialogue and hopefully some resolution of these issues.
And I think it's important for us to point out that there are people who think that they're just looking at the data and they're not aware that they have brought maybe in one case, a naturalistic interpretation to that data. That there are times where atheistic scientists will bring their atheism with them. But the reverse is also true of Christians. Christians will bring some of their presuppositions to the table. And I like your idea. Let's identify them. Now you used
everybody's got biases.
Everybody's got biases. Now we've used the word worldview. And I think we have a definition of it that we can put on screen here.
Okay.
A worldview is a conceptual scheme or a conceptual framework by which we consciously or unconsciously interpret and judge reality. So a worldview is the way we look at the world. It's like a lens in front of our eyes. In just a minute or two, we're going to talk about a pair of glasses, which I think is a great metaphor for talking about a worldview.
So it kind of colors the way you look at the world and look at reality?
That's right. I have just recently started wearing glasses when I read, and I have become profoundly aware.
Someone as young as you?
As young as me. I used to have great eyesight until I started working for Reasons to Believe and had to read too many books. But I've noticed
I
that...
guess I'm not reading enough books.
That's right. You're a little bit older than me and you don't wear glasses.
So.
I've noticed that, smudges on my glasses. I need to clean my glasses. I'm now aware that these glasses magnify everything that I look at. I like to think of a worldview in that way, and maybe to talk about some of the basic components of a worldview. Let's talk about 6 of them briefly. What are these basic beliefs that make up our worldview? Well, one of them is our view of ultimate reality. What is ultimately real? Is it an infinite, eternal, spiritual creator? Here we have them on our screen. Questions about God and reality, questions about humankind, questions about ethics and morality, knowledge, life after death, the meaning of history. And as we look at these, what is ultimate reality? Is it physical? Is it material? Carl Sagan says the universe is all there is, was, and ever will be. Or is there a transcendent creator, as Hugh Ross suggests, that the universe that we know, there is a creator beyond it. And so all of these, humankind, what's our origin, what's our destiny, morality.
Well, get a little more specific, more than just questions, say, about ethics. I think what exposes worldview is, where do ethics come from? What is the source of ethics?
Right.
What is the origin of humankind? What is the origin of the universe? So often you can get started on these worldview issues, or particularly with people that are resistant and conceding that they have a worldview. Well, tell me what you think about the origin of the universe, or where does morality come from?
Right.
helps you get on that track.
How do we ground these views? These are foundational beliefs, and we're going to have other beliefs that will be built on top of those.
Right.
Later, we'll have a graph that will illustrate that. Now, I think a very effective way of speaking about worldviews is to talk about a pair of glasses, and I've agreed to put these glasses on. I kind of feel like a rock star here with these glasses on.
Ken, that's you. Those glasses are you.
They really
me.
fit you. Ken.
I know the students who watch
Especially
the show.
those pink stars. They really make it.
Well, I appreciate that. I'm going to pass them on to my colleague here in just a minute and make fun of him. A worldview is like a pair of glasses. Everything I now see is filtered through these lenses. And I remember Hugh and Fuzz a couple years ago, I bought a pair of sunglasses that were just supposed to be the best thing since sliced bread. I think they said you could look at a nuclear blast and it wouldn't harm you. They were just wonderful glasses. And when I got them, I noticed two things about these glasses. One, they did allow me to look up into near the sun. A lot of the glare from the sun was taken away. I could see things a little more clearly when I drove. And so, like a good worldview, they brought reality into sharper focus. But I also noticed that there were problems with these glasses. It distorted color. So when I would look at something yellow, it would make it look white. And that's very much like a worldview. A worldview can bring reality into sharper focus, or a worldview can distort your interpretation of reality. And so we all have lenses on, even someone like you with wonderful eyes well into your 50s, we all have worldview lenses that affect our views of reality.
So, I mean, what we could be saying here is that if a scientist, for example, addresses the question about is God real by saying he rejects the notion of the supernatural, he rejects the notion that there is a God, when he looks at nature, just like when you looked at something that was yellow and saw only white, he would look at nature and not see any evidence for God, whereas
that's right. It's a
Christian who believes there is a God, when he looks at nature, he sees evidence for God's fingerprints and God's activity.
That's a terrific example. I remember listening to a scientist lecture one time in which he said during his lecture, he said, I only believe in the things that I can observe and the things that I can logically infer from observations. And I went up to him afterwards. I said, do you realize that you can't observe the idea that you only believe what you observe? So he was obviously bringing presuppositions. He was bringing his worldview to the data. And so I think scientists, like everybody else, have to be fair-minded, and they have to attempt to identify those presuppositions and sometimes realize that their presuppositions may color the data.
Now, I always think it's good for scientists when they write a research article for publication in the opening paragraph or two to kind of lay out where they're coming from. This is my perspective. This is my educational background. This is the interpretation of the worldview I'm bringing to this model of nature I'm investigating here. And to some degree, this is fairly common amongst cosmologists, astronomers who study the origin of the universe. They will typically lay down their cards in the opening few paragraphs of the research paper, making the point that they're coming from a non-theistic perspective or a pantheistic perspective, where they believe the universe is all that there is, or they're coming from a theistic perspective, so that we have an opportunity to evaluate their analysis of the physics of the origin of the universe in that context and compare it with people who hold different worldviews. But in other disciplines of science, that's usually completely missing.
And I think what's so positive about that kind of thing is that it really puts in perspective this false criticism that only religious people have ideas that color their interpretation, when in reality we all have presuppositions.
That, right.
Because all of us have religious ideas. We either believe religion is valid or we don't, or there is a God or there isn't a God. So all of us have religious viewpoints.
Well, why don't you tell us how this worldview concept affects the way people look at science? That's
great. We have, in fact, a graph here that I think is really important. relating worldviews in science. It even asks the question, what
is
constitutes science? What is science? What is in the parameters of science? What role will we allow for a transcendent being? Is there anything outside the box of the universe that is physical? What data is admissible? So will we look at anything outside of the physical? Will we look for transcendental explanations? How do we evaluate the evidence would be another one. And what kind of conclusions are allowable? I mean, some scientists would say right from the get-go, I'm not going to even allow for there to be something of a supernatural explanation because everybody knows the material world is all there is.
Well, and when this comes to, for example, the theory of evolution and the evidence that supports the theory of evolution, what you see happening is because many evolutionary biologists reject supernatural explanations or reject at least the use of supernatural explanations in the way they operate in science. They may believe that there's a God, for example, but they reject the implementation of that explanation in the way they conduct science. And you look at life's history, and you see that different life forms have existed in the fossil record at different times. Life has clearly changed. It can't be a supernatural explanation. It's got to be a natural process explanation. And now you're backed into the conclusion that evolution is a fact. And now what becomes testable is how did evolution occur? But you see what's happening here is it's a philosophical grounding that's forcing this conclusion that evolution is a fact, not the scientific data drawing out that conclusion.
Yeah, great
well,
point.
Ken, both Buzz and I have been to scientific academic conferences and meetings where these scientists will get together, and they may not say it directly, but kind of how it all begins is, we all know there is no God. And given that there is no God, this is how we have to interpret the data. And no one ever comes up and says, oh, wait a minute, what if there is a God? Wouldn't we be looking at the data a little differently? It's like that's considered to be even taboo. It's like, hey, we all know God doesn't exist. Let's go forward.
Well, the sad thing is now the goal of science is not discovering the truth, but discovering a plausible natural explanation,
Right.
which is a very different enterprise.
Right.
And if a person is left in a circumstance where they think, well, evolution is the only game in town, it's the only interpretation around, they're left with that. They're not going to be considering other alternative explanations.
Well, one of the questions you had there in your list, Ken, is, what is science? And often what happens to color or force people to put on all the same pair of glasses is a definition of science that is really much narrower than what science is really all about. They'll make such claims as, well, science only deals with the natural realm. Science only deals with natural causes. If the supernatural is brought up, that's simply outside the limits and the bounds of science, and it's forbidden even to discuss that possibility.
Right.
So there are taboos within certain disciplines of science that simply forbid the possibility of looking at anything other than a naturalistic explanation.
Yeah, we have the concept, the term methodological naturalism. I'm going to begin with, and through this scientific process, I'm only going to consider material physical causes. And this to some degree, places the Christian within a point of tension, because we believe that we certainly should take the data revealed in the created order seriously. In fact, Scripture tells us that we must do that. But we also believe that there is some data given to us via the Bible. So should we limit all of our sources of knowledge merely to what we can observe and discover through observation, or should Christians allow for this other data to bear an impact?
Well, I think you can even push this into the arena where, as Christians, we believe that God does have a role in how the record of nature looks. In the sense that Christians putting on different kinds of glasses may take the perspective, well, God intervenes infrequently through supernatural means, or God is intervening all the time. And so the whole question is, as we look at the record of nature, is our expectation that we will mostly find natural causes to explain the phenomena we're observing, or is our expectation is almost going to be entirely supernatural causation?
Right.
You know, we're coming from the perspective that God is conservative in his miracles.
Sure.
Performs as few as possible to achieve his purpose. So predominantly, we're looking for naturalistic explanations. But in no way do we claim that it's all naturalistic explanations. We expect that there will be frequent examples of supernatural intervention.
And Fuzz has even coined a term, weak methodological naturalism, which
Right.
would be, I think, much more in keeping with a Christian theistic view.
Right.
Now, let's take a look at how a worldview functions. We have three principles here about how a worldview would affect our understanding of things. Our three principles would be, number one, that a worldview affects how we interpret the data. It's the lens that we bring to bear. Number two, a worldview involves a network of beliefs about God, about knowledge, about reality, etc. Morality. Three, a worldview can cause us to avoid or force fit data. Maybe we find data that doesn't seem to fit with our preconceived ideas. And we have to decide, am I going to avoid that? Am I going to revise my theory at that point? Am I going to be honest and admit that my worldview, in fact, may have a conflict with this?
To put it in a biblical context, Romans chapter 1, it's a natural tendency of every human being to suppress the truth.
Yes.
So to some degree, we're going to be tempted to avoid data that doesn't fit or challenge our worldview. And so we should expect that that's going to be normative for all of us. You know, through the Holy Spirit, we can be delivered into a humble response to nature. We say, hey, I'm willing to have my worldview challenged. But our natural tendency is going to be to avoid that.
Well, and that's why it's so critical to be willing to put our ideas to the test, to do science and to do our theology in a community where others are holding what we're doing to a high degree of accountability.
Right.
And where we're holding other people to a high degree of accountability as well.
Constructive criticism is the name of the game.
Right.
We have to be willing to give it, and we have to be willing to receive it.
Now let's take a look at how worldviews affect how we interpret data. We have two scenarios here, and we're going to deal with the question of UFOs, seeing lights in the sky. You and I are quite familiar with that, having just completed a book on the topic.
In fact, isn't that in the title? What is it? Lights in the Sky
and Little Green Men. Yes, it's right there.
Not sure I like the title, but it's appropriate.
Now, let's suppose we have two scenarios. First of all, we have a person who believes in UFOs, and they say, I see lights in the sky. Well, what is their foundational belief? How will I interpret this data? Well, I believe that there are UFOs, and so their foundational belief really interprets the data that they see, and so they come to the conclusion that those lights in the sky are none other than UFOs.
Mm-hmm.
So their foundational belief is the filter for what they see.
So their glasses make them think that they're really seeing UFOs.
That's exactly right. And more than 5 million people in this country claim to have been abducted by physical aliens.
Abducted? Not just see UFOs.
Not just seen them, but abducted by aliens and nuts and bolts crafts. So now how would I explain that? They are bringing their beliefs to whatever unusual experiences that they have. Now, not everybody believes in UFOs. There are a lot of people that are very skeptical, and you and I would be very skeptical of most UFO claims. But some people would start with the foundational belief, I don't believe in UFOs. I don't believe there are any kind of UFOs at all. They just are not what they claim to be. Now, they see the lights in the sky, but in light of their foundational belief, they say, well, what I'm seeing here must be a misinterpreted natural phenomena. Maybe I'm looking at a B-1 bomber. Maybe this is an advanced aircraft. And so again, their foundational belief would be the filter for whatever they see.
Sure.
And so here I think are two good examples of how that would work. And worldviews, again, involve an interconnected number of beliefs. And I think a good way of picturing this is to look at a pyramid. I'm not advocating pyramidology here or any kind of financial scheme.
Okay.
But we have a pyramid. Worldview beliefs are interconnected. And I want to start right at the bottom with our foundational belief. We bring our foundational belief of naturalism or theism or pantheism, and building on that foundational belief, whatever it may be, the second ring in the pyramid, we have related beliefs. And so we would look at the data through that kind of scenario. Moving up again on the pyramid, we have dependent beliefs. And so you can begin to see how a person is going to build their conclusions based upon those beliefs as they're laid out. And so worldview thinking is very critical to expose, and there we see it completed. It's really important for us to ask people, how does worldview analysis affect your conclusions? That's really, I think, what we're trying to get at.
And you got a good scenario here that'll help exemplify this for us.
Yeah, I think these models work very effectively. And let's take a look at one more thing. How do I arrive at this belief? Creation isn't scientifically testable.
Very common statement.
Yeah, common statement by many scientists.
Yeah, so we look at that foundational belief and we say, well, since there is no God, since there is no supernatural realm, the physical universe is all there is. That's my foundational belief. I then move up to my next related belief. Science excludes all supernatural explanations. Building on that, creation explanations stultify or inhibit scientific inquiry. Religion is not helpful. And then I arrive at my conclusion. Creation isn't scientifically testable.
Right.
And this is not necessarily based on sound data. This is based largely upon a person's foundational worldview.
And it's very ironic to me that younger creationists hold the same paradigm of beliefs, that the creation isn't testable, based on completely different worldview biases and perspectives. So often the same conclusion can be drawn by people coming from opposite worldview perspectives. I mean, I saw that happen in a three-way debate I participated in up in Santa Clara. Young Earth creationist Dwayne Gish, Eugenie Scott, the non-theist, the National Center of Science Education, both of them were saying that creation isn't scientifically testable. And so I think it was really revealing to the audience to see these two very opposing worldviews come to the identical conclusion. Then I step forward and say, I don't agree with either of these people. I believe that creation is eminently testable. But I had a different worldview than both of them.
And I think it's a very powerful support for any view when you're able to say, what would the world be like if the Bible were true? What kinds of things would we expect to find? I know Fuzz does this a great deal. What would we expect to find if creation were true or evolution were true?
Yeah, what would it be like if the Bible were not true?
That's right.
And how does that fit with what we see?
Yes.
So in that sense, we can really make progress and put these things to the test. But I think that's distinctive. I mean, a lot of people, the worldview that testability is impossible. And, we're putting out a worldview that says it's eminently possible, and here's how you can demonstrate that it's possible. And we'll pick up some examples of that for you next time. Thank you for joining us.